in the present context. Friends, artificial intelligence is the simulation of human intelligence processed by machines, especially computer systems. Specific applications of artificial intelligence includes expert system, natural language processing, speech recognition, and machine vision. It is a wide-ranging branch of computer science concerned with building smart machines capable of performing tasks that typically require human intelligence. It leverages computers and machines to mimic the problem solving and decision making capabilities of the human mind. First and foremost, my hearty welcome to all the guest speakers of our today's webinar. Dr. Deepak Shuddalwar, Professor and Head, Computer Center and ICT, Department of Engineering and Technology, NCERT Bhopal. Professor Kiran Sri Pokkuluri, Professor and Head, Department of Computer Science, Sri Vishnu Engineering College of Women, Andhra Pradesh. Professor Dimitrios Karas, National and Kapodistrian University of Athens, Greece, and Ms. Shubhangi Tandon, Applied Researcher at eBay, California, US. I also extend a hearty welcome to the chairperson of today's webinar, Dr. Praveen Joshi, Director, Prerna College of Commerce, and the guest of honor, Dr. Ujjwal Lanjewar, Principal, Prerna College of Commerce, Nagpur, India. Before we invite our first guest speaker to address all of us, I would like to invite Dr. Ujjwal Lanjewar, Principal, Prerna College of Commerce, for his introductory remark. Over to you, sir.
Okay, thank you, Neha.
Thank you, sir.
Am I audible to all of you?
Yes, sir, you are.
Okay. Very good afternoon to one and all. Honorable Professor R.C. Gulane, President, Prerna Seva Mandal. Dr. S.C. Gulane, Secretary, Prerna Seva Mandal. Our guiding source, Dr. Praveen Joshi, Director, Prerna College of Commerce. Today's eminent speakers, Professor Dr. Deepak Shuddalwar, Professor Kiran Sri Pokuru, Professor Dimitrios Karas, Ms. Shubhangi Tandon, faculty members, and my dear students. I welcome you to all in this webinar. It is a great honor for me to talk to you today on this very exciting occasion. I am delighted to have the opportunity to address such a talented and hardworking gathering of students. This is a great day for us, and I am very happy to be sharing it with you. Mixing and mingling with young peoples are one of the great pleasure of my job. As a principal of Prerna College, I must understand the youth listening here. I always try to bring excellent and knowledgeable resource person to deliver the talks on this type of platform. I always encourage interesting areas of research through this type of webinars. By listening, we can adapt to changing trends and respond to new ideas globally. The major driver behind our transformation has been our strategy to listen, observe, monitor, and then act. Thus, we have been able to implement thoroughly unique curriculum, one that aligns directly with the need of society. Friends, our today's topic is artificial intelligence and its global impact. The global impact of artificial intelligence will be profound. To some extent, it already has been, and much more development lies ahead. International business growth, artificial intelligence, and global expansion often go hand to hand. The McKinsey Global Institute recently analyzed economic data from United Nations, the World Bank, and the World Economic Forum, and reported that by 2030, AI has the potential to add around 16% or about $13 trillion to the global economy. It could also boost the global gross domestic product by up to 26%. McKinsey also report that by the same year, at least 70% of companies are likely to have adopted at least one form of AI technology. Perhaps computer vision, advanced machine learning, natural language, robotic process, automation, or a virtual assistant. The global economic impact of AI is already substantial. AI impact economic growth in a variety of ways, increasing productivity and trade opportunities, better management of complex product units, expansion of digital platform. Global expansion and AI have had a fruitful partnership. AI helps companies expand globally in numerous ways, such as easy expansion through digital platform, accurate translation services, improving trade negotiations, supply chain management, automating routine tasks, increased efficiency and accuracy. Artificial intelligence is likely to impact global expansion in the future much more forcefully than it does today. One reason is that the adopting new technologies and incorporating them effectively takes time. AI's impact on the global economy will be 3 times higher in 2030 than it is today. In future, artificial intelligence is likely to impact global expansion in different ways, such as improving prediction of future trends, increase smart manufacturing, increase ability to pass evidence and make conclusions, increase automation of tasks, more reliable autonomous vehicles, increase accuracy and efficiency, increase focus on business innovations and cost effectiveness. To achieve the latest knowledge about AI and its global impact, we always try the groundbreaking approach to the integration of teaching and learning that emphasize the discovery of new knowledge. In today's world, young people need to know how to generate new knowledge to meet the demand of the modern day's workforce, to practice professionally at and beyond the level of international standards. We have reached this stage by listening and responding to the world around us. A strategy that will benefit you to progress a new job, a new career, and a new life. I hope that hereafter you all will enjoy the 3 momentful, knowledgeable sessions and learn a lot. Thank you. Thanks a lot. Now I hand over to Neha madam. Thank you. Neha madam.
ठीक है सर, हम देखते हैं, जस्ट अ मिनट सर. Vidya madam,
Yes, ma'am.
Shiddalwar sir has led the meeting. Kindly allow him to re-enter.
Yes, ma'am. Yes.
Kindly give me a second, please. Excuse me. Extremely sorry for the interruption. Actually, the guest got left from the meeting, so that's why there was a technical issue. Our technical team is handling the issue. Kindly give me a second.
Ujjwal sir. Ujjwal sir, you are
Yes,
muted.
sir. No. I am now.
If there is any problem,
Yes, sir.
the next speaker is with us. You can start with that.
Yes. I will try.
Dr. Kiran, she is there. He has already
Yeah.
joined.
Yes, sir. I will just. Yeah. Okay, sir.
Neha madam. Vidya madam.
Yes, sir.
If there is any technical issue on the part of the speaker of this
Yes, sir.
particular, you can take the next speaker. He is available there, Dr. Kiran Sri.
Yes, sir. Yes, sir.
So you can request him.
Shiddalwar, sir. Am I audible to you, sir? Shiddalwar, sir. Am I audible to you, sir?
No, his mic is muted, I suppose.
Sir, kindly unmute yourself.
He is not audible to us.
Yes, sir. Sir, I'll call him.
इसको क्या हो गया? नेहा, इशू सॉल्व हो गया? नेहा?
Yes, sir.
Yes, sir. Yes, sir. Issue
Yes,
solved.
sir.
अच्छा, ओके.
We are going with our second guest, Vidya madam. Vidya madam.
I think Dr. Kiran Shri is here. Dr. Kiran Shri.
Yes, sir. Dr. Praveen, how are you, sir?
you?
Fine, fine, sir. Please.
Welcome to Nagpur, though virtually.
Thank you very
I'm
much
very,
for the
very
invitation.
thankful to you that you have readily accepted our invitation.
It is my privilege to be associated with you, sir.
And I'm sure the participants will be immensely benefited from your talk on a very
Definitely, I made the
important and
presentation.
expert topic.
Yes, yes. I made the presentation very simple and it will be live.
Yeah. Please,
It
please
will-
start. Before that, I think Neha is going to give you an introduction to the audience. Yes, Neha, start please.
Yes, sir. Thank you so much, sir. My sincere apology to each one of you. Sorry for the inconvenience. Now, moving to the next session, and for that, we have a very distinguished personality with us, Professor Kiran Sri Pokkuluri, Professor and Head Department of Computer Science, Sri Vishnu Engineering College of Women, Andhra Pradesh, who will address us on the topic Recent Advances in Artificial Intelligence. Dr. Pokkuluri Kiran Sri has received his BTech and ME in Computer Science and Engineering from JNTU, Jawaharlal Nehru Technological University and Anna University, respectively. He has obtained his PhD degree in the area of artificial intelligence from Jawaharlal Nehru Technological University, Hyderabad. He has authored 6 textbooks for UG and PG students of engineering in artificial intelligence and published more than 96 research articles in various international journals and conferences. He has filed and published 7 patents in the area of deep learning. His bibliography was listed in Marcue's Who's Who in the World, 29th edition, 2012, USA. Professor Kiran is the recipient of Bharat Excellence Award from Dr. G.V. Krishnamurthy, former Election Commissioner of India, for 2 times, and recipient of Rashtriya Ratna Award. Presently, he is working as head and professor in Department of CSE at Sri Vishnu Engineering College for Women, Bhimavaram. He is the Global Vice President of WSA, World Statistical Data Analysis Research Association. So now I request Professor Kiran Sri Pokkuluri kindly to enlighten us. Over to you, sir.
And thank you very much for the nice introduction. And thank you, sir, for giving me this opportunity to share my insights on various aspects of artificial intelligence. I will just try to share my screen. Is my screen visible, madam?
Yes, sir, it is visible.
Visible, okay.
Ji.
So good evening, everyone, and I am Dr. Kiran Sri. And the topic that I have kept for this particular webinar is recent advances in artificial intelligence and deep learning. So the topic is apt for this webinar. The reason is last week, Gartner has released the top 10 promising technologies that can disrupt the world. So one of the technology that was listed in this top second position is artificial intelligence and deep learning. That is the reason whatever aspects that I'm going to discuss today will have some significance in the terms of how can if somebody were biased or somebody are interested in building an AI system, what are the things that they need to learn. And before starting, I thank the organizers for giving me this opportunity. And this is how I have planned my session. A very simple session. The most emphasis of the session is to provide various applications of AI and deep learning. Indirectly, it creates a research ambience among all the various people who aspire to do research in this area. That is what my focus is actually. So the entire presentation concentrates on this part. Before that, I will start about four various mechanisms that we have in artificial intelligence. What are the four mechanisms? And then I will try to discuss about what is the difference between a traditional system and an AI system, and what exactly is machine learning, and what is the disadvantage of machine learning, why we need to go for deep learning. This is what the topics that I have kept for this particular webinar. And this is my first slide, which says, like, if somebody thinks about artificial intelligence, like if some of the activities of a human being, if it is done by a system, we can call that system as an AI system. If some system or a computer exhibits some intelligence, we can call it as an AI system. Many other definitions are there, but it depends upon like how to use the definitions. Very recently, you have a definition on AI, like when AI is integrated with IoT, then we can have a robust AI system. So many definitions are there. Like whenever you wish to design an AI system, or whenever you wish to propose an expert system, most of the people will think about, can you develop an AI system which can think exactly as a human being? This is not possible, because nobody or a system cannot replicate the brain of a human being. It is an ideal case. It's very difficult to achieve this part. Can you design a computer which acts like a human being? This objective can be achievable, because we can train the system and test the systems based on some at least trained actions. We can make a computer which acts like a human being. It's what this is very important. This is an important objective. This can be achieved, but can we design systems which think rationally? It's very difficult objective. Can the computers can think logically? It's very difficult until unless they are trained. So acting rationally is an objective that can be achieved. The reason is we can design systems and can train some actions, and these systems can act with respect to some logic. So if somebody asks me what is the disadvantage that AI has, is AI does not apply any common sense reasoning. So common sense reasoning is something like I am sitting in a room where opposite to my room you have a classroom. So the title of the classroom is a learning room, that was written on the top of the class. So artificial intelligence system will read that as a learning room. Whatever activity that is done in that system, in that class is learning. So whether you shout or whether you dance or whatever you do, it will not apply the basic common sense. It will only go through the rules. So artificial intelligence systems cannot apply common sense until unless they are trained. So my interest of keeping this particular slide is like these two objectives can be achievable, and most of the expert systems, whether you take Mycin or any other Persian system, all this will be acting rationally or acting humanly or in a combination of them. So we can understand about artificial intelligence better if you see these particular applications. Like I have in this particular slides that I have kept it for this webinar, I have used an advanced application of artificial intelligence here. I have used a old application of artificial intelligence here. So the application that I have used in this particular is called as Deep Blue. This Deep Blue is developed by IBM. where Deep Blue is a system which facilitate the way of a chess game. Like, you can play a chess game with this. The reason that I have kept this Deep Blue is like this Deep Blue has defeated Gary Kasparov in 1993. At that moment, this Gary Kasparov is one of the top chess playing person. At that time, not only Deep Blue, we have something called as Rebel, that was a system which implement this chess game. But the thing is, like I said, at a system which exhibits some intelligence in is an AI system. So you need to understand, like at least it will take a small game like this, because chess is a bigger game. We call this game as a tic-tac-toe game, where you have only 9 boxes to be played and 2 players will be playing this game. If I keep an A here, the opponent can keep a B here. So the next turn is A, so I can keep a here. So B will be placed here so that the winning of A can be hindered. So what does A will do is A will keep himself here so that B will not win. So again, the move from B will keep this here, and so on and so forth. What will happen is you will have either A win or B win, or it go for a tie. So what is that you need to understand here? When 2 players are playing a game, how do you know what will be the next move of a person? Like if A is there, B is there. Out of 9 vacant places, we have 7 empty places. Where exactly A can be placed? And if A is placed here, we have 6 vacant places. 1, 2, 3, 4, 5, 6. So where exactly B has to be placed? B must be placed here. So can you predict the moves of opponent in can you predict this in future? Like when you are having like this, see, when I play A here and B here, the next move will be A. The next move will be B. So can you predict the moves of the opponent? Based on that, I can win. Is what prediction is. This chess game is also simple. This is a 3x3 matrix, whereas chess game is an 8x8 matrix, where 16 things will be there here, and 16 this will be there here. They will move based on some certain conditions. But what is interesting is, like, if what is the way in which opponent plays and how he is moving from one place to other place, and based on the movements of my opponent, how can I predict my moves so that I can win, is very important. So these are the systems which exhibit some intelligence. To my RHS right hand side, I have something called as, I kept something called as a Tesla. This is a Tesla, where a Tesla is the name of the company which produces semi-automated or automated cars, like driverless cars we can think. But what is interesting part is, what is the technology that was behind this Tesla is a deep learning technology to 60%. So when it is moving from one state to other state, it has to depend upon the left neighbor, right neighbor, front neighbor, back neighbor, and it has to perceive the sounds. So you have a car nearby. If it horns, what is that? It has to perceive this voice, and it has to think that there is a car nearby. And how can at real time your deep learning systems can process voice, can process images, can process video, and so on and so forth. And if for information, these Tesla cars, they can go for self-parking also. How much space is needed and how much space is available, how can you predict at real time, is what the specialty of this Tesla's car is. So Tesla is the latest application of artificial intelligence, where it needs to predict what is the left neighbor, what is the right neighbor, what is the front and what is the back neighbors. Apart from that, it has to process the videos as well as audios at real time. Then it has to give the correct output. Then it can move from one place to other place. So based on that, it can go for self-parking, it has self-cross control. How can it follow this Google map to reach the destination? All the things are a big technological myths or technological advancements in deep learning. So again, here I have kept two very important expert systems of artificial intelligence. We call this as Sophia. Sophia is called as a humanoid robot, where the specialty of the Sophia is it can interact with people, it can give expressions. Here, Sophia is taking a class for 8th class students. It can answer their queries at real time. And now the latest version of Sophia, if you see, it can also identify the sarcastic laugh of the students. So you need to understand you have a system which can process your voice, which can process your video and able to analyze whether the laugh that you are giving is a sarcastic laugh or a genuine laugh. Or when you pose a question, they will answer this. So you need to understand that we have systems in deep learning which can process images, which can process voice, which can also process video also. So Sophia is a humanoid robot which is tested and trained to do almost 76 different functionalities of human being, taking a class, interacting with students, answering this and identifying obstacles and so on and so forth. At the other hand, we have an expert system called as Mycin. Mycin is an expert system in health informatics. You give set of symptoms to this Mycin, it will tell you what are the diseases that are attributed to this Mycin. What are the diseases attributed to the particular symptoms? This is the basic functionality of Mycin. But if you are able to give the blood sample from there, if it takes this DNA sequence, it can give a more profiling in the terms like it will assess the way in which the symptoms are there, and if it has the profiles, it can predict what type of diseases that you are going to prone in future. This is what we call it as a Mycin is a prediction system, which takes some inputs as some symptoms and it will predict the diseases. Not only a particular disease statically, but also it can predict the diseases dynamically in future also. So based on the habits that you have, based on the DNA sequence that we have done, it can predict what will happen in future, what type of diseases that you are going to have in future. Now, if you see the latest version of Mycin, it is trying to process the X-rays of people, and this Mycin is able to find out whether that X-ray is prone to COVID or not. So earlier, the interesting fact that you need to understand is earlier Mycin used to interact with people in the terms of text. Now it is interacting with people in the terms of voice. And now if you give a video also, this Mycin can easily process that video and can give you the disease attributed or the possible disease that is attributed to the symptoms or whatever things that you have. So if you wish to use Mycin, like most of the doctors are using Mycin to assist the patients to prescribe medicines without side effects. This is the most important part of Mycin, and Mycin have a lot of advantages that you can take. And if you see here, most of the people know about this particular software called as Hawkeye. Hawkeye is a system which was built based on the artificial intelligence, which predicts the deviation of the ball once it was pitched. It gives the deviation, it gives the displacement, it will also give the height of how much height it can travel once it was pitched. So Hawkeye is a real-time video analysis system which gives you once the ball pitches, is there any probability that this ball hits the wickets or not, or how much deviation it will take, how much displacement it can take, and how much height it can take after pitching the ball. So it's very difficult to process a video and tell this. So we have systems which process videos and have this type of analysis also. We have seen a lot of things in this, in cricket, even football also. So earlier we used to do face recognition by using MATLAB. most of the time now we are using this with Python. So if somebody asks me what are the languages that are pertaining to artificial intelligence, I can say it is Python, I can say it is MATLAB, I can say it is R. When we are studying BTech in 1997, we used to have a language called as Prolog, and this we call them as A languages at the time. But now whatever activities that we have done in Prolog at that time, now we can do very easily in Python itself. So inbuilt models are there in Python. So if you wish to go for deep learning, you can use TensorFlow. If you wish to, or you can download this Keras framework and apply this deep learning mechanisms. So wherever you go, whether you go for Twitter or Facebook, this face recognition is there. Face recognition, edge detection, and all the other all other problems can be solved by using Python very easily than MATLAB. So that is the reason most of the people call this Python as AI language now, because most 60% of AI people are using this particular language called as Python. So I intentionally have kept this. The reason is we have more sophisticated systems called as IBM Watson. IBM Watson is an expert system, which is basically a question and answer mechanism where we question the system, it will give you an answer. Earlier, IBM Watson was only into health informatics, but now IBM Watson is into insurance, IBM Watson is into football, health informatics, many other fields. Is IBM Watson is serving its, it is having its own expertise here. So earlier, IBM Watson is to interact with people in the terms of text. Now IBM Watson is interacting with people with respect to voice. Now we can interact with IBM Watson with respect to video also. It can process. It is having that capability to interact and do all the other activities that can be done. So IBM Watson is a question and answer mechanism where it will ask several questions. Based on that, it will give you answers. Like you ask, like, I have 6 fingers in the hand. What is the reason for having 6 fingers? My height was white since my born. What is the reason for having that? I'm suffering with a chronic disease. Then IBM Watson will tell you, based on the DNA sequence, it will tell you whether it is inherited from your father or mother. And a lot of other things that you can find it from IBM Watson. So this is a drone technology that most of the people now are using. It is an integrated technology with respect to AI and IoT, where we can sow the seeds. We can this drone can automatically take snapshots of the crop, and based on that, we can find out whether the crop is in fertility or not, or whether the crop is diseased or not, based on the analysis that we have. Because we have already the snapshots of plants which are good in the terms of healthy leaves, what are the sick leaves, and based on that we can go for analysis. Most of the people now, they are using drone technology to monitor the farming, and also not only showing these fertilizers, it's also just telling when this this farm is going to go for ripe, and what is the fertility that you have, what is the yield that you are getting from this crop. So much analysis will be done by using this drone technology. So we have various voice apps. You can take it as Siri or Alexa, or we have Google Home. All these are voice apps where we can use them. Like earlier, we used to have AI systems which can process only text. Now the AI usability of AI systems has become more in such a way that these 3 systems, which are also prediction systems, which interact with people in the terms of voice, for not only playing music or alarms, more sophisticated features are available now in Siri or Alexa or even Google Home, based on the versions that you procure. All these are AI systems, and I have intentionally kept this because most of the smart house applications are applications which are integrated with AI and IoT, which is the most important feature. Like we can say that this is the most important and vital part of AI, because when AI is integrated with IoT, you will have a better sophisticated smart apps or smart smart, whether it can be equipment, or you can call it as equipment. Means my interest is like you can call it as a TV, or it can be alarm or whatever it might be. When AI is integrated with IoT, obviously you'll have a better sophisticated futures. So this is like most of the people know about this Google Maps. Like I wish to travel from Hyderabad to Delhi. So then it will give me the shortest path, and considering the traffic, now it is also considering the conditions of a road, and it also considers the traffic that was there and many other parameters. It is going to suggest this is a better path at this moment, because this is every time when a Google Map is used as a prediction at some point of time. And these are the various applications that we could find in artificial intelligence. All my discussion that I am doing, if my intention is, if somebody wish to develop an AI system, what are the things that they have to keep in mind? That is about my interest. That is the reason I have changed my slides very simply. Like we have a weather prediction system, which is the most important AI system that we have seen. Like I wish to find out what will be the climatic variations in Nagpur in October. So if I have the information of the climatic variations in the last year, you can predict what type of weather you will have in Nagpur in October this year. So if I have a data of 1 year, that is, I have the data of 2020, so I can predict something what will happen in 2021 October in Nagpur. But this is a static data that is already available. So at some point of time, at now the time at this, if I say like at 5:30, what is the chance that there will be a drizzle in Nagpur if somebody asks me? So if I have the statistical information here, like today, if it is 4th, in the last year, 4th of October, is there any rain or not? If you say that at 5:30 there is no rain, it is not the exact prediction that will happen. Actually, that is a static data that is already there. So what should be there is like just a minute. So what is that which is necessary is like whenever you're predicting weather, you have a static data. We have a static data. We call this static data as a data that is already existing for the last 1 year. So now what is that we can do is what is the precipitation at this moment? What is the humidity at this moment? What is the distance between Earth to the nearest cloud? All these factors will vary with respect to time. Precipitation at this moment will vary with respect to time. Humidity at this moment will vary with respect to time. The distance between the Earth and the nearest cloud will also vary with respect to time. So when you wish to design an AI system for weather prediction, all these parameters has to be there. You need to have a static parameter, and then you need to also have this dynamic parameters. Then only you can predict a better AI system. The same way, you have something called as a stock market prediction. There is some disturbance. Just a minute. There is a small disturbance that is coming from somewhere. Praveen sir, is my voice is audible and it is clear?
Yes. You are
Yes,
audible,
sir, you
sir.
are audible.
You are audible.
There is small disturbance somewhere. Okay, anyway. You can see my screen, is it right?
Screen is not visible now.
No, sir, your screen is not visible.
Okay, I will share it again.
Kindly present again, sir.
Yes.
Now
Now
it's
it is
visible.
visible, sir.
Yes, yes. So I wish to find out what are the variations of reliance. What are the various variations of price in the Reliance shares in October? And if I have the information of how this Reliance is doing for the last 1 year, I can predict what exactly will be the shares in October at some point of time, like 15th of October 2021, I can predict. But what is essential is like you have a stock market that is affected with news. Somewhere somebody says that Reliance has given official statement that it is starting new outlets in Delhi. The stock market stock price of Reliance will change, and at least somebody says like there is a war between Pakistan and India, the stock market price or value of this Reliance will also change. So my interest is whenever you're designing an AI system, you have static data that will be there, and you also will have dynamic data that is in the form of news, in the form of political decisions. Sometimes there is a fake news also that will affect the stock market prediction. So all these are the dynamic factors that will affect your AI systems. So when you're designing an AI system, what is important is you need to have static data that is true, and you need to also accommodate this dynamic data, which will give you a robust AI system. And we spoke about IBM Watson is an AI system which takes input in the terms of various DNA sequences and give you a lot of analysis. Like I said, what is the disease causing gene, whether it is inherited from a father or mother. If you wish to disable the right hand of one's body, what cells will do. And so much analysis can be done by using this IBM Watson. But the interesting fact is IBM Watson is a question and answer mechanism. And the next most important application that we could see here is a crowd counting systems. If you go to IIT Madras, you have almost 10 PhD scholars, they are working in these crowd counting systems, where these crowd counting systems, what they do is they will analyze the video at real time. They will analyze the video at real time, and they will tell you for every minute how many people are in that video. For a span of 1 minute or 2 minutes given by the user, it will give you how many people are located in that video, the first thing. And second important thing, what does it will do is it will also find out how many people are having these abnormal actions in that video. How many people are having these abnormal actions in that video, maybe which can where they can damage to the infrastructure or whatever it may be. It depends upon how you train the system. But what is that you need to understand here is you have crowd counting systems which process videos. It will give you the number of people in that particular video at that moment, and it will also give you who are the odd men, like who are the people with abnormal actions, based on the training that was given by the systems. So then we can have COVID-19 systems. Like I wish to find out, I have a big enterprise, I wish to find out how many people in my enterprise are following this social distancing. You have almost 76 systems which process videos, and it will tell you whether these employees are following social distancing or not. And we have several systems which will tell you whether the employees in that particular system or particular society are using masks or not. If they use the masks, whether they're keeping the mask properly or not. So these two systems are like masks. We have almost 160 plus systems are there, which can process the videos and tell you whether you're holding the mask or not. If you are holding a mask, whether it is properly fixed or not. And we have almost 76 different systems which are developed in deep learning to process videos they will tell you whether whatever videos that you have, like what are people in that video, whether they're having that social distancing or not. If you see the latest version of COVID-19 systems, they can easily scan your X-rays, and they will easily tell you whether this X-ray people who are having this X-ray are prone to COVID or not. So we have a system which is trying to process these X-rays and find out whether these X-rays are prone to COVID or not, infected with COVID. With these two classes, they can classify. So recent advances in, particularly in artificial intelligence, we can call it as this COVID and CC systems. So in shopping, most of you are aware that most of the people are shopping is done online now. So when the shopping is done online, you know that like yesterday we are searching for procuring some laptops in our institute. So surprisingly, once I use, when I open this Facebook, all the recommendations I am getting is from this laptops only, like Dell and so many other companies, like from Amazon I'm getting, even Flipkart. See, the thing is, how can the profile, like how can a system can monitor the activity of the person based on the searching? Like in Amazon, like if a customer is there, what type of goods he has procured, based on that it will suggest you a lot of other goods that he's probably can procure in future. It's same, like not only shopping, it can be in music recommendations. The way in which you're watching or you're listening to the music, the same theme music will be suggested to you. All these are AI systems. They will read, like they will process your inputs. Like I procured some mobile in Amazon, if you assume, like the next suggestion will be some pouch. Next suggestion will be something around a lid or it, or a temper glass, or whatever it may be. It depends upon how do you analyze the shopping behavior of the customer, and how the next shopping activity that is done by a customer can be predicted, is the most important thing in artificial intelligence. So by the time you reach the last slide of applications, you must understand that whenever you are designing an AI system, you need to have static data. You need to also must have dynamic data. Static data is a data that is already there with you. So this is history, we call them. So dynamic data is a data that will change with respect to time. When both of them are amalgamated, you will have an AI system with some accuracy and some reliability. You are aware that in Calcutta in 2019, Government of India has started e-challan mechanism, where in national highways you have CCTVs installed in that highways, and these CCTVs are installed with speed guns. So whenever a vehicle exceeds the amount of speed at that moment, at that instance, the speed gun will ignite the system, and the CCTV systems will be activated, and they will take a video. And from that video, they will get set of images. From that images, they will get the car number. So what will be done is instantly each challan will be sent to the corresponding email of the car number. It will be done with 0.7 nanoseconds. So e-challan mechanism that was used by the government of India is an application of deep learning itself. There is hardware called a speed gun. Whenever the speed gun, you assume that if they are crossing more than 80 kilometers per hour, this will ignite the system. Once it was ignited, the video will be captured automatically, and from the video you will get the images. From the images you will get the car number. From the car number, automatically an email will be sent to the people. This is how this email challan mechanism is used. And this is a very important application that we could find in artificial intelligence and deep learning. So we have a chatbot where we have many chatbots which provide initial information when you wish to go for e-commerce websites, or you go for banks. These chatbots will interact with you like, how can I open my account? It will give you the static data that is available. And we have an interesting chatbot with a lot of features. We call it as Eliza. We have different versions of Eliza, where this Eliza can interact with people, and it will find out, it will ask you many questions. How are you? How was the day? And many questions it will ask you, and it will give you the mindset of the person at that moment. So chatbot is a very simple application of artificial intelligence, where you can have the chatbot in Ada, or you can have it in Python also, where very simple, like less than 10 minutes, we can design a chatbot with minimal features. So AI is everywhere. Like, that is what I wish to tell. AI is everywhere. AI is integral part of our life. We are living in an environment at some point of time in a few years, like as per the Gartner says, within 1 or 2 years, you have only 2 types of people who know something about AI, who does not know about AI, or who know about machine learning, who does not know about machine learning, because AI is everywhere. We are using AI in AAA department, we are using this in civil, mechanical, everywhere. Now AI has become so diverse, and it's the applications, many real-time applications, whether it is a COVID or to have this different type of sensors, we can use this AI. So the applications of AI are global, and for most of the applications, AI can address this, give you solutions. So we have a lab called as robotics in our Vishnu society, where we work like computer science. 50% of people from computer science and 50% of people from mechanical will build the robots. So the ambience and creation of the robot will be done by mechanical, and we code them. Like, we have 5 different type of robots which will move from one place to other place to take some prescribed utensils. This is what we have developed. And everywhere, that's what I said, AI is everywhere in the health sector. We have seen this particular machine in navigation, like Google Maps, your AI will be there. So these slides, whatever I kept intentionally for this particular webinar, will definitely create some interest in creating an AI system. This is the reason that I kept more applications, which will give you more emphasis on how to use an AI system, and how can we easily create an AI system. So AI system is different from normal systems. The reason is AI system, normal systems, we take the input, we write the program, and we'll get the output. But in AI system, it's not the case. Like, we have the input, we have the output, we will try to get a model which will fit into this input and output. This is what we are going to do in artificial intelligence. In machine learning, mostly what is that we do is we'll try to build a model, or we'll choose a model in such a way that this our input and this output will get. So there is a lot of difference between what exactly machine learning will do and what exactly AI will do. So a lot of people will ask me, what exactly is AI, what exactly is machine learning, what is deep learning? A deep neural network is deep learning, actually. But all these are subsets. You could see here, like if you have, like, if you wish to implement artificial intelligence, you can implement this by using machine learning, or you can implement by using deep learning. So you have less data and less number of features, then you go for machine learning. You have large data and you have more number of features, then you better go for a deep learning. This is what in general people will say. In machine learning, if you see, we have various techniques, like we have various methods, like we have supervised learning, where class label of the data was given. In unsupervised learning, there is no class label will be given. And reinforced learning, where we are going to learn in the terms of feedback, that is what it is called as. In robotics, we do this part. In this simple thing, like when can I go for machine learning, when can I go for deep learning? We have machine learning, we have various drawbacks of machine learning, like see, the way in which you store data inside the system will depends on the efficiency of this one. When the data increases, the accuracy will decrease. When the futures increases, the accuracy will decrease. That is the reason we have to move towards from machine learning. You are moving towards deep learning. So in supervised learning, various mechanisms are there. We can see them. And in unsupervised learning, when the classes are not given, also we have various mechanisms. And this is why we are going for machine learning in particularly. Just a minute. So if you see the graph here, most of the machine learning algorithms will have a plateau like this. This is if I say it is 10, the performance is 10 at this moment, performance is 10, performance is 10, performance is 10. But if the amount of data increases, the performance of deep learning algorithms will increase. That is the reason if the data is more, we will be shifting to deep learning. So deep learning is something like a deep neural network where we have set of inputs that we have to take, and based on the inputs we process. If I wish to process a particular image, I can go for CNN. If I have a sequential data, I can go for recurrent neural network. If I wish to compare something and I have a sequential data, I will go for long short-term memory because RNN extension is LSTM. Or I have some cut short of correlated data, then I can go for LRU. LRU is also one of this RNN. When I wish to apply this deep learning in cyber forensics, I can go for JAN. So all these are various models that I wish to keep only the names of the models because each model will take at least 40 to 50 minutes for discussion. But what my intention is like if you have a nonlinear data, then you can go for support vector. When you have linear data, you better go for random forest. This is how I wish to just have this particular insight. So various deep learning models are there. Like if you wish to have a sequential data, you wish to process natural language processing statements, you can take RNN or LSTM. Now people are talking about TNN, Terra Neural Network, and you have some papers which is integrated of RNN plus CNN. Many papers are there. So we have various techniques which will now, based on the functionality that we have to choose a model. That's what I said. When the data is more, you go for unsupervised learning algorithms because they can handle this, whether it is a k-means or something like that. So these are the references that I have used, and because the images that I have not referred or cited, that is the reason I kept this disclaimer, because the images that are used is only just for education purpose. And I have to thank the management and Praveen sir for giving this opportunity to share my insights. If there is a chance, I can come again and specifically we can talk about deep learning algorithms or supervised algorithms at some point of time. Thank you very much, sir. Thank you, sir.
It's
Thank you
really
so much, sir.
wonderful.
Yes, sir.
And you have explained everything very categorically in a very easy language so that even the new people, new students also can very well understand. That's excellent presentation. And I have no words to thank you enough. It has been really wonderful.
It's my privilege, sir, actually. It is my privilege to be associated like
If,
this.
Neha, if anybody has any questions to ask, they may do so.
Yes, yes.
Participants, if you have any query or any question, you may ask or you can send it to the chat box.
Sir, the session is recorded, sir?
I will have to ask the staff. I don't think that it has been recorded. Neha, have you
So
recorded
actually, it is streaming live. It is
Live.
streaming live. Yes, sir.
Streaming
YouTube
live.
Streaming. Yes, sir.
Okay. So we can have that. Is it, madam? I can have that live link.
Can we
Sure,
send
sir.
the...
Sure, sir.
Yeah.
IBM Watson is an AI system. Basically, IBM Watson is a question and answer mechanism. You ask a question, it will answer. Like I asked IBM Watson earlier when I'm doing my MBA in Anna University, like what is the reason for having 6 fingers? If you have the DNA sequencing, it will tell you why there is 6 fingers. If you are suffering with some chronic disease, it can tell you whether it is inherited from your father or mother.
Wow.
Lot of inputs it can give when it has your profile in the terms of DNA sequence is there. So IBM Watson was not only in health informatics, it was also in insurance, it was also in stock market. See, I wish to keep 10,000 in stock market. What are the promising stocks that where I can go for? This is the question that you have asked. It will give you answers. IBM Watson is work like Google. It is not like that. Google is a very big database. IBM Watson is into health informatics and only 3 domains. So whenever we have AI systems are systems which are personalized systems. Like I can have an AI system for predicting weather. The only objective is to predict the weather variations in the terms of rainfall, in the terms of temperature, in the terms of wind and wind speed. So it cannot predict other things. It is trained like that. So you have stock market prediction. It can only predict the variations of various stock that is already trained and tested. You have a machine. It will work in the terms of health informatics. So if you take Rebel, it will only think about implementing the chess game. So the domain is fixed for these expert systems.
Nowadays, these weather predictions come true.
Yeah, it is more.
Earlier,
Yes,
earlier it was like that.
yes, it is more
Whenever
likely.
the whenever the Met office declared that it would be raining heavily, that time it would be sunshine.
Yes,
And
yes.
whenever they said it will be sunshine, it would rain. These Met offices earlier were not so correct, so accurate. But I think with the introduction of artificial intelligence, now our weather cop is behaving properly and
Yes, sir.
giving us correct predictions.
Even in US, if we have standard weather predictions, it will say at 3 o'clock there is a rain in US. It will be rain only. So that type of accurate prediction systems are there in US. But the weather predictions are local, sir. You can have a weather prediction system which is working very good in Vijayawada. The same system may not work properly in Nagpur. It depends upon the particular local conditions at that moment. How can you accommodate the dynamic changes into the system? At that instance is what the reliability of the system.
In the field of medicine also,
Yes, sir.
this artificial intelligence is being used to a lot of extent.
Yes, sir.
And one of my very close medical friends told me that a day will come that doctors or pathologists or radiologists, they will not be able to befool people, because with the application of artificial intelligence, the people will be able to diagnose themselves at home only.
Yes, sir. Yes, sir. What is that now people are doing is like if you go to the WHO website, you have something called a link about COVID, this mycin. So earlier I said in the mycin, just if you give some 5 or 4 symptoms, they used to give some the disease that is attributed to that particular symptoms. But now what is that? It has almost 256 different type of versions. If you scan if you give an X-ray of a particular person, it will tell you whether this X-ray is prone to COVID or not. Such kind of lot of subnormal features are there, particularly for these AI applications pertaining to health informatics. So it depends, it depends upon the available data. It depends upon the accuracy that we have trained and tested also. But reliability, like if you take mycin, most of the doctors are using mycin to prescribe the medicines to the patient without side effects. It can be a supplement at some point of time, but you cannot rely on the system straight away.
But one of my apprehensions in the field of medicine is that today the parents cannot know through hospitals whether they are going to have a baby boy or a girl boy, right? But I
Yes.
think with the passage of time, if artificial intelligence area is expanded, so even I think that will be easier for them to diagnose whether in pregnancy in the mother's womb it's daughter or son. And don't you think that it will have very bad effect on the society?
No, no, that is possible, but it is not allowed actually. If we do that, even in IP government also, if, even the drones particularly, even when you are monitoring these farms also, we need to take permission for this also. A can be A has some permission, has permits, sir. Actually, even not only if you see the website of Stanford, also they will say that this is the scope in which we operate, particularly for this health applications. So
Okay.
we cannot cross or go beyond the perception of what they said. But
I
there is a
mean,
possibility. It's very easy to diagnose whether it is a gent or a lady in the womb. It's very easy. It is a matter of less than 5 or 6 nanoseconds. We can find out.
exactly, exactly. No, I mean, nowadays people have got a kind of say detest for girl children, especially in Rajasthan, Madhya Pradesh, deeper part of Bihar, Haryana, basically.
Yes.
So, if artificial intelligence is applied to that particular purpose, so it will have a very disastrous effect on the society as well.
Yes.
So,
Yes.
as you say, artificial intelligence should also be licensed, and what
Yes.
applications should be used, that should also be delimited.
Yes. Yes. It is clear in artificial sir. Wherever we are using this technique or technology,
Hmm.
we have many limitations. Even for drones, also we have many limitations to
Right, right,
just monitor the farms also.
right. Even brain diseases, I suppose, nowadays can be diagnosed with artificial intelligence.
Yes, to some extent, we can predict, sir, in the brain diseases because we have standard CNN and RN systems which can predict what are the various movements of the brain, whether that is productive or unproductive, whether they're static or dynamic, whether they're passive or volatile, something like that.
Thank you very much, Dr. Kiran Singh.
Thank you, sir.
We
It's
are
my
very grateful to
privilege.
you. Let there be a formal vote of thanks. Yes, Neha, please continue.
Yes.
Thank you so much, sir, for such an informative and educative session. You have elaborated the topic so beautifully. Thank you so much again.
Thank you. Thank you
Friends,
very much, sir.
thank you so much, sir. Friends, the third session will be conducted by Professor Dimitrios Karas, National and Kapodistrian University of Athens, Greece, and Sir will address us on the topic artificial intelligence, human intelligence, and labor substitution. He works with National and Kapodistrian University of Athens. He also works as an adjunct professor, Ganeshi Lal Agarwal University, Mathura, India Department of Computer Science. Formerly, he had worked as an associate professor at National and Kapodistrian University of Athens. Earlier, he has worked as an adjunct professor, Epoka University, Department of Computer Science. He was also a former associate professor, PhD in Technological Educational Institute of Styria, Hellas. He was also a former associate professor at Central Greece University of Applied Sciences. His profile is very prolific, but constraint of time do not allow us to read out his impressive profile at this moment. So I request Professor Dimitrios Karas to enlighten all of us on the topic artificial intelligence, human intelligence, and labor substitution. Over to you, sir.
Thank you very much for your introduction. Thank you all for being here. I'm delighted to have such a talk with you, a speech about artificial intelligence. I'm professor, of course, in artificial intelligence, intelligence systems, and applications, distributed systems, and so on. But my talk today will be, because you are a college of commerce, and I would like to focus on the impacts of artificial intelligence in the markets and especially in the labor. Hope to be useful. I will try to
Sir, one
be
minute. Sir, 1 minute.
not very long because there are many transparencies.
Joyce, 1 minute, please. Ours is a commerce
Yeah.
college, it's true, but at the same time, it has science faculty as well. So there are commerce students as well as science students.
Okay.
We have
Yeah,
IT also.
I know. You're a computer science department. But of course, I think you are willing and to see applications and so on. It's not only theoretical computer science, let's say, but it includes also the application domain and the impacts to society. So this is what I thought. Social networking. We all have our smartphones all day long. We have a data-based economy. We are based on online learning in many cases, including COVID now case. We have we try for sustainability, and the technology includes not only AI, machine learning, deep learning, and neural networks, let's say, but one of things, autonomous vehicles, smart robotics, robotics in general, blockchain technology now, nanotechnology, quantum computing, and so on. And of course, regarding finance, we have online payments, web banking, cryptocurrencies. We have several impacts of technology in finance, and all this stuff creates new values. What is important is that since 2000, almost, as you see, 500 companies have disappeared, actually 250 from the 500 companies of the fortune have disappeared. And since 2000, almost since 2000, because the web started 1995, but since then, we have a digital economy, which, of course, changes all life. And AI is a part of this revolution, let's say, but we will talk more about this. You see, and you know from your life, what was during 2005, and now through smartphones, you don't need, of course, global, let's say, tables, screens, or whatever. You have your own screen in your smartphone. Everything goes digital. And, however, in order to see the impacts, we could borrow some, let's say, talks from Bill Gates, for instance, where we always overestimate the change that will occur in the next 2 years, but underestimate the change that will Gates says here is that we talk too much about what will happen shortly, but we will not catch, and we don't catch, what happens in decades. So, as we see, and we already know, technology and especially AI now on has replaced the classical, the traditional energy and banking companies in the top ranking of revenue of companies, in the profits. So you see now the best companies are Apple, you see Amazon, you see Alphabet, Microsoft, and Facebook, of course, but these are not the only ones. And all this, or nearly all this, are based on AI technologies. For instance, Microsoft provides platforms for AI in business through Microsoft Azure. Amazon, of course, provides the cloud with AI capabilities. Facebook too, it uses AI in depth and in many applications. And we move on from exploitation of data, let's say, of technologies, etc., into exploration more and integrative technologies with AI. This is the exploration. Exploitation was one upon a time when the people, the engineers, they used, as human beings with human intelligence, they used technology and methodologies and so on. Now we are in an era of exploration, automatic exploration of data and frameworks, building of frameworks for this. And of course, something fundamental is changing when you see the revenues, when you see the number of employees. For instance, you can see that BMW, for instance, which is related to Uber somehow for the number of employees, you can see what is the difference and what is the ratio between them. You see Marriott, a traditional organization of hotels management, and you see Airbnb, the number of employees, and you see also with relevant profits and revenues. You see Walt Disney and Facebook in a relation, or Walmart and Alibaba. So what you see here is that newer companies using, of course, digital technologies and especially AI, they can reduce the operation costs working with fewer employees, and therefore there is now wonders what will happen with the jobs. Are there problems with the jobs? If you see this table, you see that perhaps yes, but we will analyze this issue with data from international organizations, and I will try to convince you that the danger is very small. This is the conclusion here, but be patient to walk with me in this presentation. Look this, by Mike Curtis. When you are when we are talking about Airbnb engineering and application or the website of Airbnb, you are not interacting only with humans. You are interacting only with few humans. As in Google, can you find an engineer from Google? No. You are communicating with robots every time. The same happens with Airbnb, the same happens with Facebook, with Amazon, and all the big players now. You are interacting with robots. So, of course, there are humans, but in order to interact with humans, you need to pass many hierarchies. You see also, there's a shift in market logic. You can see that large-scale producers, the old ones, which is, of course, they are too big, they go to traditional markets. But now there is, although the individuals or the small, the SMEs companies that producing now, through 3D printers, through whatever, they not reach this market, the old market. They go to the digital market. Of course, this will change also with the large-scale producers sooner or later. The marketplace, the global village, let's say market village, will be transformed to something hybrid. Okay, Amazon is fully digital, but it has stores to store all goods. They don't have exhibitions, whereas the classical market has exhibition, has shops, and so on and so on. A hybrid model is the future. Business-to-business data platforms, of course, as you can see, they increase too much. We have too many platforms now for everything, for financial services, for any kind of product, for healthcare, agriculture, logistics, industrial, social media, public sector, news, whatever, journalists, whatever, talents, whatever analytic. Here is data science and AI, and telecommunications and infrastructure. So now business is not only have face-to-face, let's say, collaborations and signatures, only discussions, etc., but all this is a bit automated through business-to-business platforms. Of course, the CEOs and the board of directors signature cannot be substituted, of course, but the work is mainly done through employing also artificial intelligence techniques through the business-to-business platform. And be careful. Now we are living in a transformation from centralized and hierarchical organizations to self-organizing organizations, and of course distributed all over the world. And Google may have something like 20 or 30,000 people working, but it's a global organization all over the world, and the robots are many more than people. And as I told you before, robots play the major role in Google, and engineers there and personnel supervises these robots, of course. So there is a room for employees even in the fully automated Google and similar giants of technology. Decentralization, of course, for payments, for whatever, for as the open bazaar, which is a decentralized eBay. So decentralization is the one of the most important trends. And you can see also that hierarchy, the old-fashioned hierarchy, is more in, let's say, in a distributed manner, like this, in a flat, let's say, level, in one level. We don't have so many hierarchies now, and the works done are, of course, more profitable here through many, let's say, freelancers than employees in the old-fashioned way. So the question, is there a revolution? This comes from the World Economic Forum. It's a question raised there during 2018. So we all know that 1784 was the first revolution, the first industrial revolution, with the trains and the steam-based machine. And of course, the mechanical production of equipment started then. It's the first industrial revolution, especially for clothing, if you know the history. Second revolution is 1870 and comprises the, let's say, Ford model for working, is the division of labor, is Taylor-Ford model. It encompasses electricity and, of course, mass production in not small SMEs enterprises, but in large scale enterprises. This happens here. And of course, a century after, we have the revolution of electronics, IT, information technology, and automated production. And now, are we in a fourth revolution, which is cyber-physical systems, robotics, and AI, machine learning, deep learning, and so on? Are we really? This is from the Taylor-Ford model, industries in the beginning of 20th century. This is the new Taylor-Ford model, the people in their offices managing the industry, perhaps, or medium and very big enterprises through technology. And here is the present and the future. Data technologies. One person to supervise the whole infrastructure of supercomputers or computers. Here is from Google. So you imagine few people supervising the work of computers. Full automation in industry, in healthcare. Even here, I have taken an example from the WordPress. The CEO of WordPress runs $1 billion company. You know WordPress. You know very well that in WordPress, many websites are built. It's fully automated. There are no offices. There are nothing. There is only a digital company, nothing else. So all this situation, of course, increases forces to local communities, building, as we will say, digital villages and so on, and presses circular economics. So we have sustainable and fully self-sufficient villages with renewable power generation, with few personnel only, fully automated. But here comes the issue. We don't know what we don't know about the future. And we know some things. You can see the percentages. And what we know is very small. What we know that we don't know, actually, but we believe that we know, you can see. But here is the biggest percentage that reveals, of course, what I want to say, that future is not fully predictable. And the thoughts about future are very important, since we are talking, or we will talk in 5 minutes, about what really happens with labor in the world nowadays. We will see how companies think about AI. So the 63% of CEOs, as an average, you can see in different areas of the world, believe that there is a very large impact of AI, bigger than the impact of internet. But the real things, the ones who have, you see the percentages, these are the beliefs, but from these beliefs, only from the 63%, only 20 or 27, a small percentage, has already applied in the cloud AI techniques for their company, for their organization. 63 is, let's say on average, what they believe about AI, but a small percentage relatively nowadays is really employing AI in full scale in their organization. And only 6% have AI initiatives in full scale in their organization for the outer cosmos and the inner structure of their organizations. And also, we see that in recent years, the organizations use, of course, digital capabilities, not a big increase between 2012 and 2018, but the leadership capabilities, which are required, of course, they believe, this is their beliefs, they believe they are not longer able to, based on public data, of course, and available data, they are not capable of being leaders in their fields, in their markets. So we have a decrease of leadership percentage, although IT is, as a belief, is in the same, let's say, it's stable about how IT can benefit their organizations. And look, this also statistic coming from think tanks as ITIF, you can see the this comes from, especially from MIT, 62% of the boards of directors believe they are savvy regarding digital technology. They are knowledgeable. Okay, they are knowledgeable. They have, they take right decisions, let's say, but based on data and the performance of these companies and these organizations, only 24% of this board of directors and upper management take good decisions, profitable decisions. They believe that they take based on digital technology. So digital safeness, as you can see, is overestimated by companies. And on the other hand, companies that use these technologies but carefully and with real savvy, in real savvy mode, they have very good profits, return of assets here, ROA, and market growth. These are important, but as you see, we have not reached this goal. So, in order to change things, only some savvy directors, knowledgeable directors, cannot change things. The board members should be in the position to understand. And as you see, 3 only. This is what has been counted from many organizations as an average. If you have 3 persons in the boards of such companies, of such big organizations, then it can change the picture of the organization and the picture of decisions, because the one only is not understood. Also, for the top management, you see again what happens in the executive management level. They think around 60% and 80% in northern countries. And you see the average. Northern countries, I mean Norway, Sweden, Canada, and so on. They have better performance, much better performance. They have transformed. They are transforming fast. These are the averages from other continents, Europe and USA, because I don't have for Asia, Africa data. So, one important thing for sustainability and the improved profits is the thinking and innovation, which is based especially in humans nowadays. Of course, desirability is a human thing. Feasibility starts from organization and technology capabilities and viability of the markets. So all this should be combined in order to have innovative products, innovation. Nowadays, this feasibility includes also the design based on AI techniques. Therefore, even innovation is something that uses AI at large. Another impact is the increasing complexity of trust, as we say. You understand? As now the services, all services become digital, we have a lot of issues in payment systems with fraud. Third party for IoT devices. We have operational problems, health and safety issues. Data integrity of data, privacy, and so on. For artificial intelligence, can we trust the machine learning and deep learning black box? Really, can we trust? The algorithms and the training bias, can we trust artificial intelligence? This is an issue. And of course, regulation and compliance. About trust, we start trust because we had SMEs, small enterprises, very small enterprises. Now with the second revolution, 20th century, we build trust, but in the institutional, in the brand name trust. And we have also now institutional trust through digital, as you understand, platforms. And in the fourth revolution, if we have started this, we are talking about AI procedural trust. So somehow we have to understand and analyze in depth if AI is able to provide real trust. So this is one thing that is critical. Can you hear me well? And can you see the screen?
Yes, sir. Yes, sir. You are audible and the screen is visible too.
Okay, because I heard something and I was afraid that I was out of channel.
No.
So what is important in this revolution, if we have started such a revolution, we have to understand the issues in the AI-enabled digital transformation. So it's a new digital transformation. So AI should be mapped in the competence of, let's say, companies. And I have to say that northern economies, for instance, the Swedish economy, uses LinkedIn through AI-enabled platforms. I don't know if other ones use LinkedIn for analysis of the talents, but not only Swedish, Norwegian economy is based on such analysis. The rest of the Europe, no, I know very well. I don't know what happens in Asia. I'm sure also, although I don't have data, that in the USA, similar things happen with the northern economies. What is important also is to make AI perform in a mature way in the large scale maturity level. And another issue is organizational performance. In the other, so it's financial, it's innovation, of course, but also in the other, I would put if there is satisfaction for the employees and the customers. You may say that financial implies satisfaction, but I think satisfaction is and quality should be taken here in the other as a separate entity. And of course, we have to analyze in this transformation the regional performance. In order to understand what happens with AI in general and the impact even in education, the majority of computer science departments focus nowadays at large in AI. You see, MIT, I will tell you that MIT is planning, now it's in the build phase, a $1 billion plan to create a new college only for AI. You understand what this is meaning? This is a trend for everywhere. So really, AI is not only in the plans, it has started. AI, robotics, and the whole digital transformation based on these technologies is a reality. So the future is already here, but it's not evenly distributed. Not everywhere we have same things. MIT has started the trend of building AI-only institutions. Perhaps this doesn't happen in, and I'm sure it doesn't happen in my country, in European countries. It started from MIT, let's say. So let's talk, if we are in the fourth revolution. So there are signs. Up to now, we have talked about being many signs that we are in a real transformation. But we have to answer if there is impact in the labor. So the normal hype is that AI and robotics will destroy jobs. We have some signs that there is a change, but I will try to convince you that this is not as big as they imagine. The pace of change will only accelerate, and some solutions provided by think tanks and investors is that to tax robots, and if you remember from newspapers, some people like Bill Gates, like Zuckerberg of Facebook, they are talking about establishing a universal basic income because AI and robotics will eliminate and destroy jobs. So is this a hype or not? We see some data coming from the World Bank. The risk of losing job is increasing, but very small increases, you can see. Also, you can see that the US labor productivity, because we have data for US, is increasing. But you will see next some other data. And coming from Schwab, which is the chairman of the World Economic Forum, the fourth industrial revolution will affect the very essence of our human experience. I believe in this too, but not in the risk of labor. So we have to adapt. There is a big hype about what happens with jobs, but there are some good news. All the repairists of the robots are humans. So the real thing is we aren't in the middle of a fourth industrial revolution. We have started. We have started only. Employment loss projections are wrong. I will convince you through some graphs and data coming from World Bank and World Economic Forum. We shouldn't panic, of course. Privacy concerns are overblown, they are exaggerated too much, and what to do? What you can see is that although productivity, I told you about productivity here, you see the productivity over the last, let's say, 20 years is increasing. But you can see from this data that the growth rates, the productivity growth rates, are decreasing. So the growth, the increasing factor, is reduced from 1995 to 2018, and you see here in 2017, according to World Economic Forum. In EU, productivity is lower. The growth is again much lower. You cannot see here, but this is for 1905 to 2005, and this is for 2005 to 2015. You can see the productivity is lower. And also, based on US Bureau of Labor statistics in US, because why only US? They have all the data. In my country, I could not find, towards this speech, I could not find all the data. There are not such analysis in European countries at so large as in USA, and the most reliable data come from World Bank, World Economic Forum, some US think tanks, and the US labor. So here the statistics show that the job losses as a share of total employment are steadily, you can see they are, it's a stationary process, and with a trend. And you can see the trend is that dislocation and unemployment is reduced. Interesting fact. So employment loss projections are not correct. I will present you again from US some professions. Look, some predictions. Minsky, the well-known Marvin Minsky, 1970. In 3 to 4 to 8 years, we will have, this was spoken in 1970, we will have a machine with the general intelligence of an average human being. Now, we know that we are even we are centuries ago from common sense machines. Common sense machines, it's a hype, does not exist, and will not exist unless centuries in the future. 1982, perhaps as much as 20% of the workforce will be out of work in a generation. So 2000, let's say 15, after 30 years, which is one generation, one working generation. No, it didn't happen at all. Nielsen, the inventor, as you know, of learning linear learning machines, if you know. We must convince our leaders that they should give up the notion of full employment. The pace of technical change is accelerating. So all this were predictions in the past. Nothing happened. Nothing happened. Also, the World Economic Forum admits that the prediction of 5 million jobs lost from AI and robots equals to 0.25% of jobs. Only 1 out of every 400 workers. This is a prediction and a predication of World Economic Forum. Another estimation is very overestimation, that 47% of jobs will be lost. This is completely overestimation. This 0.25% is near the truth. You can see some of high-risk jobs to be substituted, according to Frey and Osborne study. Dental technicians, models like this lady, manicurist, bicycle repairs, installer repairs, fence erectors, all this, school drivers, all this, according to Frey and Osborne, were candidates for substitution. Is this real? No, it's not real, as I will show. The picture nearly the truth based on ITIF think tank of US. Only 9% of jobs are at risk. Only 9% of jobs. Randomly, I selected from the study of World Economic Forum and ITIF think tank a list. There are many more, but I selected only this. Masons, brick and block, repairs of building, that is, machinists, cartographers, photographers, and laboratory technicians, social science assistants, firefighter, preschool teachers, and so on, cannot be automated. This is the new view of such professions. And of course, I believe, since I present you, that as an AI professor, I believe that technology cannot really substitute, even after a century, the preschool teachers. Impossible. Okay, a robot may teach students in universities. This is possible. But preschool teachers, no, cannot be substituted. Firefighters, okay, can you trust the robots to eliminate a fire? Really? Tell me really, you don't. Can you trust a robot as a research assistant in taking questionnaires? Really? Do you believe that such a robot can handle difficult situations with people that don't want to answer? They are even hostile. Yes. Do you believe? I personally don't believe. And so on. So we shouldn't panic. We shouldn't panic. And you will see also another thing. in 5 minutes in my transparencies. Based on Rodney Brooks, a well-known MIT professor and a very good author, we can say and we can state that technological change is not abrupt, is not sudden. There is a lot of road in order and many steps in order to have the complete transformation. So the future of transformation actually we are a generation living in such an area of transformation. Perhaps many of us, including me, we will not live in the end of transformation in 40, 50 years from now. Also, we know very well that we should change the paradigm. Up to now, intelligence is based on fast computing. We are good in this. And based on Moore's law, as you know very well, the capacity and the speed of transistors and processor is doubled. And of course, the cost is half every some years. But as you can see, the rate of increment is not as before. Cannot continue forever. This law cannot continue forever. And if now deep learning is possible, because to be honest, what is deep learning exactly? When I started employing neural networks in my research during the 90s, there was a model by Fukushima, neocognitor. This was the first deep learning model, even if they don't admit and they have forgotten today. But Fukushima neocognitor was the first thing based again on convolution, my friends, based on convolution as the CNNs and so many other models. Why neocognitor in the 90s didn't attract the interest of people? Because it seemed too theoretical, because there was no computational power for this model. Nowadays, we have, after 30 years, we have the computational power. But in another 30 or 40 years, we will not have the same increase to double, to triple, to 10, to 100 times computational power. We will not have such. And therefore, the progress, of course, we will solve many problems of AI in 50 years, let's say, but as long as our paradigm is computers and not biological circuits, because, my friends, you know, we don't understand human intelligence. We don't understand brain. We should change the paradigm. Machine learning, deep learning is perfect, but with so many drawbacks. So many drawbacks are perfect for today. They can solve many problems. They can assist in many problems, but they cannot solve 100%. they can solve, let's say, 85, 90%. Okay. It's good. For application, it's good. Now deep learning is used very widely. But is this intelligence? Can we proceed with true intelligence and conscience with deep learning and computational techniques only? Or we should change the paradigm? So I personally believe, okay, many applications, but this road cannot be forever, let's say, successful. It has some saturation. I believe that if we don't change paradigm, we will not be able to catch common sense, to catch conscience, to catch things very human, very human. We cannot catch this way. So robotics and the overlord supervising us, it's a hype, does not exist. Now our robots can dance, can do many things, but cannot supervise humans. And of course, human intelligence and robot intelligence are not equal, are far, very far from equal. So a robot is like a device. There is no human intelligence at all. Another, let's say, notice coming from World Bank and 10 world tables is that there is no correlation between productivity growth and unemployment. As you can see here, unemployment, it's stable despite change of productivity. So we will have huge productivity in the future, not now. As I told you now, the growth of productivity is a bit reduced. But I believe that this could change with intelligent machines. But this has nothing to do with unemployment. There is no correlation. There is no such a thing, let's say. There is no such a thing. There is no a line, a diagonal line to see the correlation. This is flat, no correlation at all. Okay, so in order to show you some data, again from labor organization of US, between 2010 2015. Network and computer system administrators, of course, should be reduced because now the cloud doesn't need so many administrators. Computer operators also should be reduced, automation. Economists and market researchers, we have automated tools. Taxi drivers and chauffeurs, transportation ticket agents and so on, shoe leader workers, again, randomly. You can see what happens. Okay, there is job change here. In shoe and leader workers, repairs, taxi drivers, reservation, increase of work, increase of labor, decrease here. In 11%, only computer operators are in danger, in real danger. The other ones are near the 9% of job losses. Another fact is that many workers, especially in Europe, they are, because many Europeans are overqualified. Why? Because they follow university courses. So 40% of EU workers cannot work on their subject, but they have work. what is the important with AI and deep learning, machine learning, and all these technologies is they can assist us to boost quality on several fields, like healthcare, fraud prevention, student feedback in online systems, and not only in online, also in offline systems of teaching, disability access, reduce human trafficking, and so on and so on. In many, many things, AI can boost quality, but cannot replace human. Even in healthcare diagnosis, it's good for assistance. It's good for not experienced doctors, but an experienced doctor is not able to be substituted. Believe me, it's impossible. The privacy concerns, so in order, because I see my time is finished, one moment only. So the privacy concerns is not an issue, although there are many hypes about this, many myths. The companies now, they are producing solutions through anonymization techniques for privacy preservation. And we have many, let's say, myths about governments that need AI to spy the people. These are, many things are ridiculous and theories only, but some truth may exist, but this truth is very small. It's not true that AI can spy everything through your phone or only through keywords. Okay, Echelon may spy you if you say, now I'm saying something, I'm saying terrorism. May Echelon spy me now because they are based on keywords, nothing else. They are not clever. AI is not as clever, and robotics are not as clever as they present. So what to do? We should all embrace the innovation principle. We should all push through our studies, through our research, AI and robotics to be real, to be a real fourth revolution, to increase government support of this research. And of course, we are all researchers, and therefore we should increase our plans, our projects in this research in order to make AI more mature and more reliable. And of course, we should help the other people, students first of all, but also other people too, to adjust to this new environment of a fourth revolution in the beginning, which may have impact in some jobs only, especially in jobs not requiring any intelligence. For instance, the Taylor Ford model in production will be replaced fully with robots everywhere. So we don't need workers without any knowledge. No, we need knowledge people supervising robots and, of course, playing the role of true intelligence, because up to now, AI is not a true intelligent model. Perhaps after thousands of years, AI will be similar to human intelligence, but we are thousands of years from these moments. So this was my presentation. Thank you for your attention. I hope it was, I stopped the presentation mode. I hope it was informative, and I hope it was valuable in order to justify the longer, let's say, presentation that than I wanted, because all these things are important, and I hope it was okay.
Thank you so
Thank
much,
you
sir.
for your attention.
Thank you so much, sir. It's really an informative session. Sir, there are some questions in the chat box. Can I read those ones?
Okay. Some of the questions, I don't have all the questions. Let's see.
Okay.
Because I have many questions. Well,
Yes.
many questions. This is important. I will try to answer in short all this. So I'm starting. Will all schools and colleges be closed down as robots will take over the teaching jobs? No, my friends, absolutely no. They will be good assistants. Robots will be good assistants, but they will never replace innovative teachers, knowledgeable teachers, and so on. Impossible. It's not only for the preschool teachers. It's also for the professors, for everyone. But this increases our responsibilities because a lazy professor, of course, could be replaced. This is easy. You understand, I hope. Will future wars be fought only with AI between two countries? No. It's impossible for the decisions to be drawn with AI. No sender, no command and control sender can rely on AI. AI can provide only the data for the humans to decide. So humans will be there. Now you mean about airplanes to be controlled by robots? Impossible, my friends. Even traditional airlines cannot rely on autopilots. You know very well this. There is the autopilot as an assistant, but the pilot is human. Two humans, not one human. You know very well, this will not change at all, even in thousands of years, believe me. How can AI remove poverty? Okay, although, as you have understood, I'm not I not follow completely the idea of Bill Gates that an income, a certain income should be given to all as a national or international income because the jobs may be lost. Although I don't believe completely, I believe in this truth. Although jobs will not be substituted, according to my presentation and according to what I'm thinking, I believe that a certain income, a certain increase of our salaries should happen. Why? Because since 1970, the value of our salary is always decreasing with respect to inflation rates, and therefore, since productivity will increase a lot, why not our salaries to increase a lot? I don't understand. So this way, poverty may be reduced. Can AI go beyond the control of human beings and govern the human lives? No. AI cannot supervise humans. AI is not innovative. It's not innovative in decisions. AI is only assistance, and therefore can provide good assistance for increasing our quality of life. This is true, and this is what we want. But the laws of Asimov, the laws for robots, they are good for science fiction. The Machines and Matrix, beautiful things, beautiful science fiction, but it's not true. It's not true that, and there is no truth that robots can supervise and can control human. It's impossible. I don't know in 1,000, 3,000 years if true intelligence is met by technology, then might be possible. But today, fourth revolution is not the one that will provide such intelligence. We need many other revolutions in between in order to reach intelligence, true intelligence. And something else, to understand human brain, because it's a different kind of machine, completely different than our approach. I personally believe, if we don't change paradigm, if we don't find another roadmap, I don't believe that with this technology we can reach, even in 1 million years, the brain structure and operation. It's impossible. If we change paradigm, I don't know. Maybe sometime in 1,000 of years from now, we will be able to understand intelligence and build true intelligent machines. But up to then, you can be safe and relax for your children too, and for your grandchildren too. Will all flights, trains operated only by AI? Okay, trains can be operated. In the airports, the trains are without operators. But for real missions, for long distances, with many trains and itineraries of trains intervening in stations, the large stations where we have many train lines, we will never trust non-human operators. There will be disaster. We need human operators and also human controllers, human supervisors, nothing else. Another one, thanks for sparing your valuable time. I'm from humanities background, so we used to know how far fuzzy logic systems and natural language processing affect language learning and teaching in general. Okay, I can convince you that, and perhaps you know, that, for instance, Google Translate, which is a very good service, provides good solutions, but with many mistakes. Will never replace a translator, will never understand the context. The fuzzy logic, natural language processing based on deep learning especially, is good, is very good for expressions, but not for context. They cannot understand what is the meaning. The meaning is not understood by our algorithms. We understand only that this word comes with that word, and the syntax is this or that, the grammar is this or that, but the meaning is not captured at all. Believe me, at all. So teaching of natural language only in assistance level, not as a teacher. What role AI plays in climate change? I believe nothing. There is no role. But I expect to have positive role in changing and offering some good results in a climate crisis in order to overcome climate crisis. AI, okay, you will say that, for instance, cryptocurrencies now require a lot of energy, a lot of power. This is true. But it's not these services that induce this climate crisis. And what do you think about Japan? No. Sir, my question is, what do you think how to see the world in upcoming next 80 years? I don't believe we will live dramatic changes, not me, because I will not live in the next 80 years, but I don't believe that we will see dramatic changes in the coming 100 years. I want to believe, of course, automation will be almost in any area. Of course, this will happen. I believe in sustainability. We should find some solutions for climate crisis and for financial crisis, etc., at large, so that to have again a dream life like in the 70s, because dream life after the war, it was really a dream, but only for 30 years. I believe we will reach again this dream life, but we should stop this overconsumption, because it's not sustainable for the environment, for Mother Earth, for anyone. So I believe that through AI, we can control our consumption in reasonable levels, and we can have controlled power generation in renewable energy villages. And I believe in general that the power needed, because this is the major cause of climate crisis, the power, electric power, is 60% to 70% the cause of overheating the earth. So if, and I believe we will change this certainly will be changed. So I believe in 80 years from now, in 100 years of now, we will not have true intelligence. We will have much better assistance robots compared to the ones we have. And we will have better environment and better sustainability. And of course, the great Elon Musk will bring us to the Mars or to other stars. Okay, I believe in many things. I believe, first of all, in innovation, entrepreneurship that bring technology to a mature level to change our lives for good, for positive reasons. And what do you think about Japan? Japan is, you know very well, is very good in robotics research, perhaps not in other kinds of machine learning and deep learning, but they are good at this, not the best. They are very, very innovative in robotics. Japan is perhaps 1 decade in fraud in the research of robotics and application of robotics. So I'm thinking very positively of Japan. I believe they are in the forefront of technology, but sorry, USA and some other countries, even UK, they are in the forefront of technology and innovation. You see in software, USA is cannot be beaten. You see this. At the moment, I don't know. I don't know in 20 years, 30 years. Perhaps Indian software, because it's very, very good, and Chinese may change the globe with respect to software. But for now, the situation is like this. So thank you very much. I don't see other questions. I hope I have answered everything.
It's mind blowing, sir. You have elaborately explained everything. And the summary is like this, that it is going to make our life comfortable, but it cannot be a replacement for human beings.
Exactly.
I mean, whatever.
This is my conclusion.
Yeah, exactly. And that's so convincingly you have brought about that now we are really convinced that human beings have no danger from AI, artificial intelligence.
Yeah.
And it will be our friend.
There is no real danger.
Exactly.
There is no real danger. There is only hope.
Yeah, exactly, right. It has been a wonderful delivery from you, and your presentation was really wonderful. It's a mesmerizing one, and we are really thankful to you that you have accepted the invitation, and so promptly you have agreed to deliver this wonderful talk. Very informative, very educative, very interesting.
Thank you very much. Thank you all for your attention.
Yes,
and thank
Neha,
you
please.
above all
Neha,
for your
please
info.
continue.
Yes, sir. Thank you very much, sir, for such an enlightening address. You have explained everything in a lucid manner. Thank you so much, sir. Now, friends, moving to the fourth and the last session of this webinar, we have a very dynamic personality with us, Ms. Shubhangi Tandon from California, US, who will enlighten us on the topic, the bias in our intelligence system. She is working as an applied researcher at eBay, California, US. She handles how search changes the user experience in eBay using cutting edge technology in natural language processing and computer vision. She is a technical architect in the content understanding team dealing with artificial intelligence at eBay. So now I request Ms. Shubhangi Tandon to address all of us.
Thank you so much. Okay, I'm using Google Meet for the first time, so I'm gonna try to share my presentation. And okay, I'm just gonna try and share my screen. It's not letting me record the screen. Give me a second.
There is a present now option, ma'am.
That's fine. Okay, give me a second. I just need to open system preferences and add this. Give me a second, guys. Sorry for the technical difficulties. So while I'm sorting this out, I would really like it if we made this interactive session. Okay, can you guys see my screen?
Yeah, it's visible now.
Yeah, it's visible now.
Awesome. So let's go into presentation mode. Okay, so let's try to make this interactive. I know if I ask you guys to unmute yourself and give responses, probably that could get a little chaotic, but let's try to use the in-call messages. And I just want your interaction, because bias is something, it's a term that is used very loosely in some context. It's been gaining a lot of traction in the last few years, because we have started looking at what are the ethical implications, how is the bias in our data, how is the bias in us as maybe machine learning practitioners changing the way the world is operating around us. So let me know, as future machine learning practitioners, what is your intuition to the questions that I put forward. Okay, so let's get started. What are we going to review? We're going to first start with what is the definition of bias in statistics. What is it traditionally viewed as? I'm sure if anyone has started with machine learning or statistics courses, they've looked at what is the bias variance trade-off. So we look at that. Then we look at what is implicit bias, how is implicit bias introduced. Even before you can, write a piece of code, there is still bias that lives inside of us, and what is that implicit bias. Then we look at how are we introducing bias in our machine learning systems. How can we be fair to our data, to our algorithms, and as a byproduct to the end users of the systems that we're writing, and what are our responsibilities as machine learning practitioners. So what is bias? In statistics and machine learning, we say the bias of an estimator is the difference between the predictions and the correct values that we're trying to predict. So let's say, I have some assumption about the data, and I am using that to say, hey, I think it should behave like this. This should be the prediction, but the correct value comes out to be something else because there are other factors also involved. And this difference is what is known as bias. In something like a logistic regression or a linear regression model, or maybe if you're designing the neural network, you must have seen, this B term, like y is equal to mx plus b. This b is the bias. So this is the bias variance trade-off that we have very famously seen. What does this mean? So in traditional machine learning systems, the model complexity used to be stuck mostly in two states. We were either in a high bias, low variance state, or in a low bias, high variance state. So what is the high bias, low variance state? If we look at this graph, on the y-axis, you have the prediction error of the training and test data. And on the x-axis, we have how is the model complexity increasing and going from low to high. Model complexity in this scenario means, let's say, how many features am I adding? If it is polynomial regression, are you going from, order 1 to order 2 or to maybe like order 10? So that is what the model complexity means. So when you have a high bias and low variance, what that ends up doing is your test sample is not performing that well, but your training sample is also not performing that well. Your training error is also pretty high. So what intuition can you draw out of it? Maybe the model has just not learned enough. So that means there is an underfitting happening here, and we probably need to add more features for the model to learn more or increase the model complexity. Now, what happens if I really increase the model complexity and say, hey, let me learn, everything I can from this training sample, and let's say I have 3,000 data points. Let me add 3,000 features over here. And again, mind you, we're in the traditional machine learning scenario right now. So what's going to happen is your model or your algorithm is going to learn everything there is to learn about the training data. And this training loss really goes down. Can you see this prediction error is almost close to 0? But what happens to your test data? While you were so busy making the model optimal on the training data, you forgot that the test data, while coming from the same distribution as the training data, is not identical to the training data. So your model is not robust to the test data or to the data that it has not seen yet. And because of this, your test error is really high. And in your test predictions, you have high variance. An easy way to think intuitively about variance is how much is my test prediction going to vary. So when your model complexity is low, you have high bias, probably your results will be in a certain range and you will not see a lot of variance. And that is what happens in this scenario. And when your model is overfitted to the training data, your predictions on the test sample can be all over the place, and that is what we mean by high variance. So what do you what do you want? What would be, you know, an ideal scenario for us? Now, the way the test loss and the training loss are changes for every model, depending on what the data is like, what is the complexity of your model, what model have you chosen. But let's say in this example, I would want to find that point of training or model complexity here, where the training loss is going down and the test loss is also behaving in line with the training loss. So let's say this point over here, this would be an ideal model complexity for me, because I am able to achieve, you know, some kind of low bias, low variance, you know, scenario for my model. Now, in deep learning, there is less of a trade-off, and to some extent, I believe that has contributed to the success of deep learning. So let's say you have high bias, but you can't add more data points. What can you do to reduce the bias? Well, in traditional machine learning systems, we would say, okay, let's increase the model complexity. But feature engineering comes at a cost. Adding new features comes at a cost. So what you can do here is, in a deep learning scenario, you can maybe just add more layers, and that internally, you know, adds more parameters that are defining your model. And because you have more parameters defining your model becomes more complex without, let's say, a lot of additional cost for you to spend in modeling, or, you know, even the cost of modeling. Let's say I want to reduce the variance. How do I reduce the variance? You can obviously add more data. Always adding more data it will give you a reduced variance, because your model has seen, you know, different cases that your data can take. But another thing you can do is add regularization. Adding regularization also helps reduce variance. From a Bayesian looking glass, again, this is something that I have used to derive the intuition. The prior that we define is somewhat like the bias that we have in our distribution before we see the data. So let's say X is a random variable and Y is an observation based of X. Our bias is a prior. It is telling us, you know, how do we think our data is going to perform? So this is like a very famous equation. So basically, your posterior probability is directly proportional to the product of your likelihood and your prior. What does that mean? Let's try to look at an example. Let's say you have interviews coming up, job interviews, and you've been studying really hard, preparing for these interviews. So you're going to give an interview for, let's say, Microsoft, okay? And based on your preparation, based on how many questions you've solved, how many mock interviews you've given, you say, there's probably a probability of, 70% that I'll ace this interview, I'll get the job. That is the prior that you have in you getting the job, even before you've seen what are the questions that the interview is going to ask you, what does the panel look like. Now you give the interview and you perform okay, but not as well as you think you did. So now you're saying, after giving the interview, I think the likelihood of me getting this job is probably 0.4 or 40%. So now, that you've seen the data, you're predicting that your likelihood is probably 40%. But actually, what is the probability of, Microsoft offering you the job? That is the posterior probability, based on what your performance has been. And that could probably be, around 60% because the other candidates did not perform as well too. But the prior here is basically the distribution that we think we will obtain even before, we see the data. And this prior, I think, translates to the bias that we see in our machine learning systems. Okay, so let's try to solve a riddle together. And I think this is pretty famous. So if you guys have seen this already, feel free to share the answers. So a man and his son are in a terrible accident and are rushed to the hospital in critical care. The doctor looks at the boy and exclaims, "I can't operate on this boy. He's my son. How could this be?" Okay, so how this could be is his mom is the doctor. But because in the traditional sense, we are so trained, of thinking of a guy who's a doctor, and because I showed you an image of a guy who was a doctor, you're thinking in your head, how can it be that, this guy is the doctor and he's rushing in with his son? This is what we call implicit bias. Implicit bias can come from our environment around us, from the historical data that we've seen before us, and just in the way that we're conditioned to operate. And this implicit bias lives in us as humans, and it is what we also impart to the algorithms we write and also to the data sets that we use with these algorithms. So why does algorithmic bias matter? Humans themselves have bias, and this feeds into our algorithms. But machine learning can amplify bias. It can create feedback loops, and it can compound the imbalance. Also, algorithms are used differently than human decision makers. People assume algorithms are objective or error-free. But algorithms are used at scale. And the bias in one system is being multiplied, and it is cheap to do that because these algorithmic systems are cheap. So what do I mean by that? Nowadays, at least in the United States, your health coverage, how much coverage you should get, is determined by some algorithms that look at all of your data input points. What is your comorbidity? What is your age? What are the previous symptoms you've had? What demographic do you fall in? And there were studies by ProPublica that actually found out that just by looking at the ethnic background of the people, like if everything else was same, the algorithm was likely to give a higher coverage for some racial groups as opposed to some other racial groups. And why do you think this happened? This happened because the data set that the model saw had this distribution, and it was probably a bias of the data collector, or probably they didn't look into the data enough to see, does it have any kind of bias? And now this way of deciding who should get health coverage or what should the coverage be is being used by the state of Wisconsin. It was even challenged by the Supreme Court of Wisconsin, but they upheld because it was cheap. It was cheap to use. And this algorithm has now been multiplied and used in every hospital across Wisconsin. Now, this was 4 years back. People are working on, having a more diverse data set, but only when such cases arise that we know that what are the systematic faults that we're introducing in our system. Nobody's gonna question a computer and say, the way you're defining my coverage is wrong, because the person who's gonna say, hey, this is your coverage, they don't know how the model was written. It is a black box for them. They don't know what data was used. They will say, I put in your data points and this is the output I got. This is the coverage I'm getting for you. So as practitioners, we need to be sensitive about what biases are we introducing in our systems. Okay, so let's look at how is bias introduced in machine learning systems. This is the life cycle of data generation, and then we look at how is bias introduced in modeling. So let's say, you are doing data generation. Your data generation itself is introducing historical bias. What do I mean by historical bias? It means that the world as is right now, or as it was, you're using that setting to probably predict for something that would happen for the next 10 years. And the demographic may greatly shift in those 10 years. So that is the historical bias that is coming in your data. Now, after you've collected the data, you're doing population defining and sampling. So this sampling can introduce representation bias. Let's say you say, I want to predict how long is a person going to live. And you're looking at the standard of living, you're looking at the annual income, you're looking at how big their house is. But this might greatly vary from someone living in California, someone living in Texas, to someone living in Mumbai, where, let's say size of house is really small. So you have to make sure that you're representing the population that you want to make these predictions for. Now, once you have a sample of the data that you want to model on, you start with the measurement. The measurement here means defining metrics. What is going to be a success scenario? What is going to be a failure scenario? What is a positive target? What is a negative target? Once you have those targets that you want to predict, for your sample, you have a complete data set now. And now you'll split this data set into training and test data and validation data on which you may, produce benchmarks. So in just the process of collecting data and getting ready to model, without even modeling anything, we've already introduced 3 kinds of biases in the system. So historical bias, the world as it is or was, leads to a model that produces harmful outcomes. Let's look at representation bias, because I feel like this is something that we can easily fix, but we need to be aware of, what are the problems that we can introduce. So like I said, training population does not predict target population. You're using data from California to predict the height of the representatives from Calcutta. The target population contains underrepresented groups. So the model is less robust for these groups. What do I mean by that? We'll see in an example shortly. Your sampling method is uneven. How can your sampling method be uneven? So let's say you have a task, and especially in natural language processing, how do we get labels for a task? We assign human judges and we ask them to annotate the data. So let's say you want to do something like detecting whether a comment is toxic or not. And you're asking, judges all over the world to say, does this comment look toxic to you or not? And people who have a very dry sense of humor might say, this is not toxic, this is just fine. And maybe people for whom that comment causes a cultural issue, they'll say, yeah, definitely this is toxic. So is that comment toxic or not? It depends. It depends on who your sampling audience is, who is your judge, and how are they defining that label. Another way that you can have a bias is you're using an existing data set instead of creating a new one. If you're using an existing data set blindly without knowing what is the bias that data set has, then that bias is seeping into your model and your model predictions, because you're inheriting the bias of that data set. And a lot of us are guilty of doing that. When I was in grad school, I did not have time to, go and generate a new data set because it is costly. You need resources to do that. You need people to help you to set that up, to collect a new data set. I would see what are the popular data sets available on which other people have done their research. And then I would try to beat whatever the state-of-the-art performance was on those data sets. But unknowingly, I inherited the bias of the data set that I was using, and probably it would not do well for a target population that the data set did not capture. So let's see, historical bias. Word2Vec, which came out in 2013, I think. This was one of the first, let's say, neural networks that actually changed the way natural language processing works. It was the first time, we said, okay, let us learn these embeddings for each word by learning from a very, very, very large data set. So what I've done here is I've downloaded Word2Vec, which was trained on Google News. And the 300 just means, that the size of the embedding is 1 cross 300. So every word is explained by 300 numbers. So now, if you look at this model similarity of, man and nurse, it's significantly lower than when I say, okay, how similar are woman and nurse? So the similarity of man and nurse is probably 25%, and of woman and nurse is 44%. Now let's look at the example that we saw earlier. What is the similarity of man and doctor? 0.31. Woman and doctor, surprisingly, is pretty high for this model. What is the similarity for man and engineer? 0.15. And what is the similarity for women and engineer? 0.09. So what is happening here is that in the current setting, the way, in the news, we have seen the occurrences of man and nurse together, or man and doctor together, or woman and engineer together, that is actually affecting how our model thinks, a man and a nurse are close, or, how likely is it that a man would be a nurse rather than a woman being a nurse? And this is historical bias that has implicit gender bias for this particular example that is seeping into our model predictions. Okay, let's look at this map. What do you think this map represents? So this map is basically a selection of some data. Okay. Now, if I said from this data, from the red dots, randomly select or have a fair sample of data from, from all the red dots over here, do you think the probability of the dot being in US and India would be the same as the probability of the dot being in South America or Africa? No. Even if I do a fair sample, even if I do 100 fair samples, the probability will still not be same. Why? Because your data points are more concentrated in US and India and some parts of Europe than they are for South America or for Africa. So you have representation bias here. Your selection is not reflecting a random sample for the whole demographic. It will reflect a random sample for what your data represents, but not for the whole demographic. So why does this matter? This matters because this is a map of the Amazon Turk judges. And again, why does that matter? That matters because over 90% of natural language processing tasks, which are supervised, use Amazon Turk to annotate their data. So if they have a data to detect sarcasm or to detect toxicity or to detect humor, probably they will get a very American or an Indian or a European outlook, but most probably not a very South American outlook, not a very African outlook, not a very Australian outlook. So your label data set may not have context which is pertaining to Australia or Africa. And this is how you're introducing representation bias into the system. Let's come to the last bias from data collection and generation, which is measurement bias. So what is measurement bias? We cannot always measure the target, right? Sometimes what we're trying to measure is an outcome of the target or the proxy of the target. For example, you want to build a model that says, given the student's attributes, how likely is he or she to be successful? And what you use as the target is the GPA. Sure, The GPA ensures that the student is attentive to their studies and is doing well on their tests, but that may not be the definition of a successful student for everyone. For let's say someone else, a successful student might be someone who is holistically doing well, who is also participating in sports, also participating in music. For someone else, let's say a hospital, a successful student might be someone who has a good BMI, who's athletic, who has a good mental health. So just saying, GPA is what is defining successful student here limits, what your model can do. And it is the oversimplification of a more complex construct. So you have to be very, very careful in how you define your target and how you define these proxies. And you need to always be cognizant of the fact that what you're predicting is the proxy. It's not the actual target. Now, the measurement varies across groups, and the accuracy of measurement varies across groups. Again, if I ask, judges to label the data, probably one batch of judges is doing it, during the daytime and they're really active, and the other batch is doing it during the nighttime and they just want to go home, and probably the accuracy of measurement is varying. Then we also have confirmation bias. So for ranking algorithms, let's say I say, whatever data points are actually getting more engagement from the users, that's our success. So let's say those are our targets, and whatever is not getting any engagement from the users, that's a negative target. To give you an example, let's say you go on Amazon and you click on 4 or 5 items. I say these 5 items are positive outcomes because you actually engage with them. But the other items, the other 200,000 items that you did not engage with, those are negative. Targets. So how is confirmation bias seeping in just defining these targets? Now, what happens is probably the reason that you got the positive targets was that these already had very high reviews, and if you saw that, okay, there are very high reviews, so probably this might be good, because other people have used it. So I'm going to buy this one. And there might be another identical product, which is exactly the same, but it does not have reviews, or it does not have, it does not come up on the first page, and you don't click on it. Does it mean that the item being sold on the second page is bad? No, it's not. We just didn't go to it. But this is how confirmation bias is seeping into the system. The model is now going to prefer the items that it was already showing on the first page, and diversity in items is going to be reduced. Okay, so that was how bias is introduced in data collection. Now let's see how is it introduced while building the model and implementing the model. So you have your training data now, right? You are training a model, so your model is learning. Even while the model is learning, there is a learning bias in the way the model is learning. Then the way you're defining your model, you have an aggregation bias. And I'll talk more about aggregation bias in detail later. Then you're evaluating your data on, some benchmark. Maybe that benchmark does not cover, some use case, and it completely overlooks some kind of, demographic groups. Because of that, you now have evaluation bias, because again, you're inheriting the bias of the benchmark data set that you're using. Then you actually deploy your model, you do post-processing, you integrate into system, there's human interpretation. Even in this, the way you're deploying your model, you can have deployment bias. So again, there's a lot of responsibility on us as machine learning practitioners to understand at every step, how are we introducing biases into the system. So let's look at what these mean in detail. The learning bias is a modeling choice which will amplify performance disparities across different examples in your data. So for example, you may prioritize one objective and damage another. Let's say you say, I want to prioritize overall accuracy, but in doing that, you have disparate impact on a minority class. You have an imbalanced data set. You say, just, prioritize overall accuracy. And let's say you have two classes, A and B. A is 95% of the data, B is 5% of the data. You say, I just wanna prioritize overall accuracy. What is, an optimal low-cost model you can have? Just say everything belongs to class A. You get 95% accuracy for the overall data. But if you start looking at the F1 score or the precision or recall for class B, you will actually understand how badly your model is performing. Another example of learning bias could be minimizing cross entropy, which might lead to more false positives, probably as a majority classifier, or probably by saying that the cost of misclassification into class A or class B is the same. And instead of having a weighted cross entropy loss, you actually go for a normal cross entropy loss, which assumes that both of the classes have the same cost of misclassification. Then we have aggregation bias. Aggregation bias is something, I think learning bias is something that we can be very conscious about while we're defining, how is a model going to learn. But aggregation bias is something that we often tend to overlook. So you say there's a one-size-fits-all model which is used for the data, and there are underlying groups or types of examples that should be considered differently. So a parameter may mean different for different groups. So cultural slangs might be there, for one group, which are not being considered for some other group. There might be disaggregated. So what we need to do, how can we fix this, is we need to do disaggregated evaluation. Rather than just looking at how is the model behaving for all of data, start looking at subgroups and then see how is the model performing for discrete subgroups. Also do intersectional evaluation. So start comparing for intersections of subgroups, and the experience there might be fundamentally different. So let me give you guys an example. I think 3 or 4 years ago, a very big company, car-making company, was sued by a Black woman. And she said, your company is biased against, hiring me, and it's not giving me the opportunity I deserve. Now, that woman was interviewing for the role of an engineer. The company won the lawsuit, was almost close to winning the lawsuit before someone from an ML background stepped in to help the woman. They said, look at our record of employing Black women. It's pretty high. Look at our record of employing engineers. It's pretty high. So, we're not really having any bias, or we're not really differentiating between people. So what they did was disaggregated evaluation. They showed that for different subgroups, they had parity. They were actually not at all partial while hiring people. What they did not do was intersectional evaluation, because most of the Black people that they were hiring were for construction jobs. Most of the women that they were hiring were for secretarial jobs. But most of the Black women that they were hiring was not for engineering jobs. And this is how an intersectional evaluation can help us understand what is the aggregation bias that we're introducing in our models, in the outcome of our models. Okay, the last one is evolution bias. So I think we already went over this, that we use benchmark data sets, but the benchmark data sets for a task does not represent the useful population. So some important and very popular benchmark data sets are ImageNet, Faces in the Wild, MS COCO dataset. When your benchmark has bias, then that's represented at scale with every algorithm that evaluates its result on the dataset. It can lead to overfitting to a particular benchmark. So what do I mean by this? This is the open images dataset that Google owns. And this is the graph shows, where are the images coming from? Where have the images been sourced from? And if you look at this, almost 2/3 of the data comes from the West, or from what the West's understanding might be of these images. Now, the more popularly used labels are, classifying different breeds of dogs, classifying different breeds of cats, of vehicles, and that's fine, right? Because there is some standardization in how cats and dogs, and probably to an extent vehicles, are all over the world. But there are some labels for which we see a lot of representation from the West, but very minimal representation from all over the world. So what do I mean by that? Brides and grooms. How do people look at their wedding? It's very different in Western culture as it is to maybe African culture or to maybe Indian culture. So all of these three photos on the left, the model was able to say, there's a wedding happening, there's a ceremony, it's a bride, it's a groom, there's a dress. But on the right, you have the image of an African couple getting married. And because the model has not seen, the data set has not seen these images before, and hence your model has not seen these images before, it's not able to classify these guys as bridegroom and bride, but they're just as much married as the guys on the left. So this is how, if you were to use this data, and you would say, yeah, this is awesome, I have built a wedding classifier, and I can very well say what is a photo that describes a wedding, and what is a photo that does not describe a wedding. It would work spectacularly well for all Western use cases. But as you went to African wedding photos or Indian wedding photos, it would fail spectacularly. So what should you do? When you have a model, you need to evaluate it for fairness and inclusion, right? So this is basically a confusion matrix that is explaining what true positives are, what false positives are, what false negatives are, and what true negatives are. And I'm hoping that you guys are familiar with this. So what is recall? Recall is the ratio of true positives divided by true positives plus false negatives, or of all the positives in my data set, how many are classified as true by the model. Now, if you divide your data into different subgroups and look at the recall of the different subgroups, if the recall is equal across subgroups, then there is equality of opportunity. You're introducing the equality of opportunity fairness criteria. Then let's look at precision. Sorry, was there a question? Okay, probably not. So let's look at precision. Precision is the ratio of true positives to true positives plus false positives. So of all the items your model classified as positive, how many are truly positive? If precision is equal across different subgroups, you have predictive parity, fairness criterion. And this is funny, but these criterions, ML practitioners did not come up with these. These are ethical fairness criterions that actually came up as a result of the civil rights movement in the United States. So now what model you want to use depends what matters more to you. Are you okay with more false positives, or are you okay with more false negatives? So a place where probably I don't want false positives is privacy in images, right? Let's say privacy in images is deciding to blur some images if they decide, this image needs privacy. If somebody's photo is blurred, a person's face is blurred, probably when it was not supposed to be blurred, that's okay. I can live with it. But let's say my credit card information had to be blurred, and the model decided I don't need to blur this, that's fine. And now, I am susceptible to identity theft. That's not something that I want. So depending on what your use case is, you need to decide what matters more to you, and then evaluate how good your model is doing. There is no one size fits all. So what are your responsibilities as a data scientist? Examine your data. Your data really, really matters. How are you cleaning your data? The EDA that you do on your data is very important. It's very important. You have to do analysis on your data before you start working with it. Is your data balanced? Not just with classes it represents, but with classes it does not represent. What are the skews and correlation in your data? Is your target directly related to one of the parameters, or is being unfairly influenced by one of the parameters when it shouldn't be? For example, gender and pay prediction. Are you getting inputs from multiple sources? Always, always, always visualize your data. Just by looking at some high-level statistics, you can get some intuition, but actually when you visualize your data, you will get to know a lot more. Use a held out test data set for hard use cases and make sure you're solving those hard use cases. Talk to domain experts. A lot of you might get jobs, for healthcare companies, for insurance companies, and sure, you're computer science students. You don't know, that much about, let's say, investment banking or insurance or healthcare. Always talk to a domain expert to know that you are not introducing your own bias and you're understanding what the system actually needs. What can you do for algorithmic bias? You need to know, how are you defining your targets? Is there presentation bias? Is there confirmation bias? How are you evaluating your model? You should have multiple metrics and confidence interval. One metric is not enough. Evaluate for fairness and inclusion and use machine learning. So the image on the right is pretty much how I also used to Google for a very, very long time. You say, I'll do my own research, click on the first link and say, jackpot, I got it. And what is this? This is presentation bias. I click on what comes up first and I say, this is it, this is the result. So how are we doing on time? Because I have some more stuff that we can get into technically, or we can start looking at questions. Neha?
Yes, ma'am.
Do we have more time?
Yes, ma'am, you may continue.
Okay, thank you.
Okay.
Okay, so now this part is going to get a little more technical. If you guys have questions, please ask me. So in the last slide, I said we can use machine learning to eliminate bias in our machine learning systems, which kind of sounds like a really bad feedback loop. So how can I use machine learning to eliminate bias in machine learning? We can use machine learning to debias our data. So for bias mitigation and debiasing, we can use machine learning to remove signal for problematic outputs. For example, sexism, racism. If you're working on a census data, let's say, and you want to exclude anything related to sexism, racism, you need to know what you're removing. It is not a holistic debiasing. And again, you are borrowing the faults of the model that you're using to predict sexism or racism, but your model will still be much better than had you not included these to give your predictions. Have inclusion. So we've already spoken about subgroups. So start giving attention to subgroups with the worst performance. Let's say your model is not performing well for some demographic of people or for some demographic of data. Start optimizing your model for that demographic. And probably you need to have a special classifier or one more layer in your model to do that. That's fine. Indulge in multitask learning. What does that mean? Let's say you want to predict, what is the probability of a person getting a certain disease. Instead of predicting for one symptom, predict for, let's say, other comorbidities that happen along with the disease, and that will probably help you give a more accurate prediction. So if you add multiple tasks, then underlying semantic similarities between the labels can help learn more robust joint representations. So this is an inclusion case study that was done by Google. And basically, they wanted to predict what is the suicide risk of patients. The data that they looked at was the hospital data, but they also added proxy Twitter data where people were actually talking about how they felt, before they were at a suicide risk or they were not at a suicide risk. Now, previously, they just had one target. Is this person at suicide risk or not? But then they started adding more tasks to this. They said, instead of just predicting whether this person is at a suicide risk or not, I will also predict, does this person have PTSD? Does this person have, has been having weight loss? What is their BMI? What is their build-up like? Have they had a recent sickness? What is their financial background like? So they're trying to predict for 9 tasks at once, using the same data and the same framework. And basically, there is a hidden layer or some parameters that are being shared by all of these tasks. So what happens once they add multitask learning? Basically, on the left, this is what you would get if you had just logistic regression. You go from logistic regression to a deep network, but still remain single task. Just say, okay, let me predict for suicide. This is what you would get an increase in performance. But as you say, okay, let me do multitask learning with deep learning and also add gender, you will see that the model performance increases. This might not seem like a lot, but when you're predicting suicide risk or something related to the medical domain, every bit of improvement in the model actually matters. So on the left, we have how suicide risk was predicted, and on the right, we have for PTSD, which was a minority for which we had very few examples. So logistic regression did a good job, but deep learning overfitted until we moved to multitask learning. And once we were in the multitask learning domain, we actually saw that the model starts outperforming logistic regression and actually performs really well. So we can open up for questions now if you guys have, or we can look into detail for more examples on how you can actually debias your data using machine learning. Neha, how are we on time?
Neha, are there any questions? Shubhangi, I suppose there are certain questions in the...
Oh yeah, I can see them now. I'm sorry.
Yeah.
I saw those. Okay, so how will bias variance affect machine learning for different age group students? So I think the bias variance trade-off was more in an algorithmic setting for how you're interpreting the model, but for different age group students, do you mean the different demographics that are actually viewing this? Like, what is how, as students start learning machine learning, how is that going to change? Or as they start using bias, how is that going to change? I'm not sure what does it mean for different age group students. I'll probably move on to the next question, which says, how can geographical variations bring about paradigm change in algorithms of machine learning? That's a very good question. So till now, what has happened is our researchers and hence our data has been limited to certain geographical locations. Even if you look at where the authors of conferences come from, they are most likely to be from US, from China, from India. And as a result, up till now, a lot of African related research has been ignored. So most of the translation, translation systems where you say translate from one language to another mostly started from English to Spanish, and they did not actually see how does it influence other languages that were probably not that popular. So it is only now that we are seeing people from African countries, they are coming up with their own data sets, and they're seeing their models don't actually scale that well. Models scaled designed on English to Spanish don't really scale from probably one African language to another African language. And this is the kind of geographical variation that we need to account for, because probably the researchers are in some geographic locations because of the resources, because of the focus, but that does not discount the rest of the world, and it definitely does not discount the effect it's having on the rest of the world. Okay, I think that's all the questions. If there are no more questions, that's all from me. Thank you.
That's really very wonderful session, Shubhangi. I congratulate you.
Thank you.
You have very wonderfully explained what is bias variance trade-off, and you have covered all the dimensions which are very important to understand this concept of bias variance trade-off. You have covered all the issues, and it's a very meaningful session. Thank you very much for joining us and obliging us by accepting our invitation. We are really grateful to you. Tandon
Thank you so
Saab,
much.
good evening. Tandon Saab, good evening. How are you? Yes, Neha, please continue.
Sure, sir. Thank you so much, ma'am, for such a mesmerizing session. What a wonderful sessions these were. Thank you so much to all the guests of today's webinar for such an enriching sessions. I'm sure that your talk will immensely benefit each one of us. We shall always cherish your valuable views that you all have so wonderfully expressed on this occasion. Now I request the chairperson of today's webinar, Dr. Praveen Joshi, the director of Prerna College of Commerce, to share his views.
Good evening, everybody.
Good evening, sir.
All the dignitaries, the guest, Dr. Deepak Shuddalkar, Dr. Lanjewar, the principal of the college, Dr. S.C. Gullane, Dr. R.C. Gullane, then my friend Dimitrios Karas from Athens, then one of my other friends who has joined us from Andhra Pradesh and who has recently been introduced. All the dignitaries and our young guest who has given us a very meaningful, very informative session, that is Shubhangi Tandon. I am really grateful to all the guests. They have made this evening very wonderful and meaningful for all of us. In fact, the topic is very interesting, and the horizons of artificial intelligence are expanding day by day. What today we see is only the tip of the iceberg. We have a lot to do in this field, but at the same time, it is necessary for all of us to allow our peers about artificial intelligence. Dr. Dimitrios has really done a wonderful job by removing our apprehensions about AI. I saw there was a question in which the questioner had asked whether artificial intelligence will govern human beings. The questioner wanted to say whether artificial intelligence robots will go out of control, apply their own mind, and govern the human beings the way they want. I think this question was based on a movie in which we see that robots become uncontrollable and govern the lives of human beings. In fact, it will never happen because machines are our slaves. And whenever man invents machines, man also uses the devices which can control the machines. Ultimately, all machines need power, and the power is in man's hand. No machine can ever replace human beings. As Dr. Dimitrios says, that experience can never be replaced by any machine. I'm sure we have learned a lot from these sessions, and all the sessions that we had today must have given you a new insight, a deeper penetration into the subject, and must have created in you more and more interest about the topic. I'm sure all the students and the faculty members will explore more and more in this area and expand the area of artificial intelligence. Lot of research is going on. Let us keep ourselves abreast of all the inventions that are going on, all the new ideas which are being applied in everyday life, and let us see how human life can be more comfortable, more livable with the help of artificial intelligence. Thank you all, thank you very much. Over to Neha.
Thank you so much, sir, for your valuable views. Now, I, Neha Samundre, take your leave and request Ms. Vidya Mulmule to propose a vote of thanks. Thank you so much.
Thank you, Neha Madam. Good evening to all. It is an honor for me to have the opportunity to propose a vote of thanks to all the dignitaries present over here. I am Vidya Mulmule on behalf of Prerna College of Commerce from Department of Computer Science. Since it is not possible to organize any seminar in physical mode, we have organized this webinar in virtual mode on the topic Artificial Intelligence and its Global Impact. It was not just educative and informative, but also having productive, fruitful, and wonderful sessions. To make this webinar more productive and meaningful, eminent experts from different parts of the world have given their contribution. I would like to give special thanks to all the eminent resource persons who have excellently guided the participants and shared their valuable knowledge and experiences with us. I would like to express our gratitude to Honorable Guest Speaker Professor Kiran Sri Pokuluri Sir, Professor and Head of Department of Computer Science, Sri Vishnu Engineering College of Women, Andhra Pradesh. He has elaborately explained the concept and guided us on the topic Recent Advances in Artificial Intelligence. I, on behalf of the college, profusely thank Honorable Guest Speaker, Professor Dimitrios Karas, Professor of National and Kapodistrian University of Athens, Greece, for having spared his valuable time for us from his busy schedule and for sharing his valuable and enlightening views with us on this occasion. I am also very grateful to Shubhangi Tandon Madam, applied researcher at eBay, California, US, for such a wonderful and informative session on the topic, the bias in our intelligent systems. I extend my gratitude to Dr. Deepak Shugalwar, Professor and Head of Computer Center and ICT Department of Engineering and Technology, NCRT, Bhopal. We would like to express our gratitude to all the distinguished guest speakers for sharing their knowledge on various topics related to artificial intelligence and its global impact. I would like to express our sincere thanks to Honorable President of Prerna Seva Mandal, Professor R.C. Gullane sir, the Secretary of Prerna Seva Mandal, Dr. S.C. Gullane sir, for their continuous support. My hearty thanks to our respected Director of Prerna College of Commerce, Dr. Praveen Joshi sir, for his continuous motivation and support. I must mention a deep sense of appreciation to Principal Dr. Ujjwal Lanjewar sir for his continuous guidance. I would like to thank the coordinator and members for their coordination. I thank all the distinguished participants for their enthusiastic participation in this webinar. At last, I thank all for making this program a resounding success. And with this, the webinar comes to an end. Once
And
again,
I express
thank you all.
special thanks to Dr. Neeru Tandon, who has played a very vital role in this webinar. She has provided us a very wonderful speaker, that is Shubhangi Tandon, who immediately agreed to deliver a wonderful talk and has made this evening very wonderful for us. So special thanks to Dr. Neeru Tandon.
Thank you all. I really enjoyed from beginning till end. I heard all the speakers and really enriched myself. Thank you so much.
Please continue, Neha.
Now, with the permission of chair, I declare that the session is over.
Thank you.
Enjoy the evening.
you.
Thank you so much.
Thank you, all of you. Thank you very much.
Very informative. Thank you so much.